Hello, and welcome to the first ever Fan Request Roulette here on Answer Everywhere. We're going to pick a random fan request from our list and dive into the code. Let me grab my chat. Okay, so here's our list that from fans. The project's in the first column. So so far we've got about 42 requests, and I'm undercounting some of the requests because I didn't take great notes on requests for things that were already on the list, and I may have missed some comments. But the way we're going to do this is I'm going to select the top 20 through some random method. And then we're going to choose among the top 20, I'm going to roll a die. And then every week we'll do that again. So everything will be re-weighted. I have this concept here of boosts and anti-boosts. These are things that we're going to do manually. For now, we may at some point automate this whole process. The first two requests are from people who are making requests on videos well before my channel had many followers. So I want to make sure that I get to those videos at some point. So those will have high certainty, and for this case, they'll be certain to be in the top 20. And then for users that have made multiple requests, for example, LC made a lot of really fantastic requests. But I'm going to have only one request per user per game of roulette. The other thing I should mention is that I have a 1-month-old baby, and I've been up since 3 a.m. So I'm not sure how well my mental clarity is going to be. So the first thing I want to do is I want to sort these so that we have a random sorting to pick out the top 20. I was thinking about the simplest way to sort spreadsheet columns randomly. And after thinking for a while, I think the solution was pretty obvious. So what we're going to do, I'm going to start up Python here. I'm going to grab we're going to grab the current Bitcoin price. And just to add some extra randomness, we'll grab Taylor Swift's latest tweet. Or how about we grab the first part of her tweet. And then we're just going to call SHA-256 on it. And let me see if I remember how to do this. I think I just need to encode the message, right? Great. I'll grab this and convert it to a list, which will present me with a list of integers. I'll take these integers. There should be 32 of them. Oh no, what have I done? And I might need a few more. Did I get a few more? I'll see if Bitcoin has a new price. How about we do Dogecoin? And so now we have a few more numbers. This will be called seed, maybe? And then we'll sort by seed. All right. Then we'll take the top 20. Oh, wait, I have to do two things. One is for the multiple requests, I'm going to take the top of the multiple requests and delete everything else. Can I do this? The top one is Emacs. In fact, I'm not prepared to do the Emacs one, so I'm going to drop that. And then I'll take the top one as QMU. Oops, I think I just deleted the wrong one. All right. And then the other early adopter, I'm going to have it replace whatever was on the bottom of 20. So sorry, gedit. All right. So here's our top 20. Actually, not. Yeah, so, okay. What I need is a numbered column that is starting at 1 here. I think gedit does make it. All right. So the top 20 now are WordPress, Bitcoin, QMU, GNU Mock or GNU Herd, Serenity OS. This is an error. I don't know what happened to my original. Let's see what's in the original tab. I'll have to look that up. That's chosen. Vue, Signal, Metasploit, OpenFOAM, Sway or i3, OBS, a tutorial on how I go about reading code, glibc, HTTP or HTTPS, Monero, Neovim, some sort of data-intensive application, Antler 4, or gedit. And give me a second to look up the original here. Okay, so this, do I have my mic on? All right, so this messed up request here is gnome shell. Oh no, what have I done? Gnome shell. Can I just edit this? Yeah. All right, so here's the top 20. I'm going to delete everything else here just so we don't get distracted. Actually, maybe I'll read it out for people who don't know. So the ones that didn't make it today, we're going to reweight them every week. So just because it's not in the top 20 today doesn't mean it's not going to be in the top 20 next week or next time we do this. But they are NFS, either RabbitMQ or ZeroMQ, libSSH2 or OpenSSH, Redux, Angular, Wicked Engine, some AI stuff, probably around PyTorch, Ogre 3D, which I think is another game engine, Clojure or Clojure Script, Apache Spark, SQLite, Xterm or some other terminal emulator, ZSH, X or Wayland, Quake, and Proof Assistant, either Lean, Coq, or Agda. So those are not going to be that's not going to be what we look at today. Now let's roll a D20. Originally, I wanted to spin a roulette wheel, but my wife strongly discouraged me from buying a professional quality roulette wheel. And she's probably right. All right, 17. And 17 is Neovim. All right, let's do it. I'm going to assume it's on GitHub. Okay, I'm going to clone the code just so I have it in case I need to look through it in Emacs. Oh, so I'm seeing some chats. OpenBSD is a good candidate. Hey, yeah, it is a good candidate. Hey, Hanson chat. Hello, Samur and Sajad and Marcel Oslat. OpenBSD is great, Marcel. If you wouldn't mind making a comment on a video, yes, you can add suggestions. Anyone can add suggestions, but I guess for the purposes of this, we'll close it out. I don't know. Let me think about that. Well, I didn't see this chat in time, but maybe we can do suggestions next time. The other thing I was thinking is maybe one boost can be if people in the chat want to see certain things that are on the list, we can have that be a boost to the weighting. So that won't necessarily guarantee that gets to happen, but that way, if there's like excitement among the people, the audience who's watching live, that's something we can take into account. All right, so here's Neovim, and truth be told, I don't know anything at all about Neovim. I use Vim occasionally, or VI, and I actually don't really know the difference. But you're also you're an Xugler. Yes, I agree. I miss code search every day as well. There are like, I think the Chromium source code has like a version of code search that's not terrible, but it's a sad remnant of the internal version. All right, let's see. I guess just so I have my bearings, let me look up Neovim on Wikipedia. It's a fork of Vim. I don't know what era it is. Let's see if we can find when it was. From 2015, so 7 years ago. So this should be maybe a modern spin on Vim, perhaps, that strives to improve the extensibility and maintainability of Vim. Some features of the fork include built-in language server protocol support. Okay. Support for asynchronous I/O, and support for Lua scripting using Lua JIT. It has a configuration syntax, the same configuration syntax as Vim, Thus, the same configuration file can be used for both. And if the added features of Neovim are not used, Neovim is compatible with most of Vim's or most or all of Vim's features. All right, cool. So you know what? Just for sport, let's see if I think I have Vim. Maybe I have VI. Let me see if Geeks has Neovim. Seems to. I don't know how good it is without any configuration file. It's like Emacs with no configuration is probably unusable. Yes, thank you, Sajad. It's a Vim fork. That makes sense. That's about all I knew about it, I think, is that it's some version of Vim. I didn't even know if it was a fork versus like a new implementation. So what if I just call Neovim? What's the binary called? NVim? Okay. I can exit. I can exit in the standard way. We get a message about Uganda, which is pretty cool. I've been to Uganda. How do I open a file? I don't know. I know I can open a file by like, if I do maybe nvim and then dot, I should probably get a directory. Okay, this is good. But there's no hope of me like actually browsing here. Let me see if I can open a source file just to see what we get out of the box. How about bit.c? Lua bitop. So we get syntax highlighting. I don't know if, I don't think there's any hope that, oh yeah, I can right click. Okay. So let's take a look at the code. So if it's a fork, some of the code should go back to Vim, right? Or the fork, it's a Vim fork. No, wait a second. So Vim should be Vim and VI improved, right? Okay, so Vim is a clone of Bill Joy's VI. And let's see, Vim goes back to 1991. All right, and there's some forerunner from 1987. Was created by Tim Thompson for the Atari ST. Really? So so Neovim, its great grandparents are from the late 1980s on the Atari ST, which is different from the Atari game machine, I assume. And that makes it a few years older than Emacs, right? (1976) is the first Emacs. Okay. They actually removed a lot of Vim code, says Emusa. The new Vim code base is smaller than the Vim code base. That's probably a good idea. Hopefully they removed a lot of Vim code that was kind of outdated or whatever. All right, so I'm going to guess most stuff is in source. We do get tests. We have this .editor config. I don't think that's so important. We have a list of backers and some stuff about maintaining. And it's mostly Vim. Whoa. If there's more Vim script than C, and there's nearly as much Lua as C, that's really surprising to me. Now that might be, maybe most of the Vim script is like test or something. We've seen that in some other repos where a significant amount of the repo is tests. But I always thought of Vim as primarily a C editor, but it's not. It's nearly as much. It's nearly as much Lua in Vim script. So now we have to know what Vim script is, or at least I want to know what the syntax is. Do you think Wikipedia will have a separate? No, it's part of the same thing. Vim script. Also, okay, so Vim script, also called Vim script with no space or Viml, is a scripting language built into Vim, based on the X editor, language of the early Vi editor. Did I pronounce it Vi or V? Early versions of Vim added commands to control flow. Commands for control flow and function definitions. Since version 7, Vim Script also supports more advanced data types, such as lists and dictionaries. Wow. And a simple form of object-oriented programming. Built-in functions such as map and filter allow a basic form of functional programming. So it's a scripting language. It's not just configuration. So here's an example. Echo hello world. And here's a loop. We've got this let thing, let I equal 1 to declare a variable with no types, I guess. And then we get a while loop. I don't know if we have for loops. And then we have end while. I don't know what this style is called, where you have, Bash has this sort of thing too, where you have a thing, you have another thing to end it. And you call unlet, I guess, is that free? And then you set off the stuff inside the while loop by probably 2 spaces instead of a curly brace or something like that. And there's no colon like there would be in something like Python. Great. And while we're here, maybe I'll ask Bard, what are the top 5 reasons people prefer Vim to Emacs? Vim is more efficient. It's designed to be used primarily with the keyboard. Once you learn the Vim commands, you can edit text much faster than you can with a mouse-based editor like Emacs. Bard, what are you doing here? Vim is more lightweight. Vim is smaller and more lightweight. Yeah, so this is why I use Vim, because Vim or VI or some version of it is installed on every instance of Linux. So like, if you can get a shell in like a small container, you often have VI. You almost never have Emacs. In a lot of like, small containers that you would use, for example, for microservices or whatever. So Vim is more customizable. I don't know if it's more customizable than Emacs. It's more portable. That's possibly true, and has a more active community. Are these true? I'm not sure these are true, Bard. Let me ask ChatGPT. Legacy of Algol. Case. Oh, okay. Cool. I didn't know that was an Algol thing. Thanks, Samir. Samir? Let me know if that's the right. That's a good pronunciation of your name. Is it a version of Samir? I know of Samir, but this U is tripping me up a little bit. Okay, wait, are these the same reasons? You get efficiency. Simplicity. Do we have simplicity here? No? Okay. Availability. Portable is basically the same as availability, and VI compatibility. The simple and intuitive. I don't know if anyone's ever described the VI interface as simple and intuitive, but maybe Vim has a more intuitive interface. Quick edits. Okay, cool. Yeah, Jarvix, sounds like you really want X Windows. I appreciate it. If people, it's nice to know when people are really interested in something, because if they're excited about something, I'll take that into a case. Take that into account or whatever. Samir. Okay, Samir. Is the emphasis on the E? If you Google VI, yeah. This is a Google Easter egg. Did you mean Emacs? I mean, this is how. I think one of the things that I did when I was at Google is like, I was curious, like, how do these Easter eggs work? So I would like look up some of this stuff. Oh, thank you. I'm glad the quality is good. It's if you go back to the beginning, the quality hasn't always been good. All right. So where are we? But I did just update my like my mixing board thingamajig, and I think it's a little bit better than what I was using before. All right, so here's Neovim source. We get a few C files, including bit and sealant. Now, I don't know why, and a Lua file, and Lua 0, and coverity, which I think is coverage. I'm going to guess nvim is the place to be. Man is probably man page. CJSON is probably CJSON bindings. I don't know what klib is, but that doesn't seem so essential. And then the other things like Unicode and xdiff make it seem like a lot of these folders are not so essential. So I'm going to guess everything's in source/neovim as far as the C code goes. And this looks pretty good. Very cool. Did I open test? Let's just take a peek in tests just to see what's here. We have a benchmark, which is kind of interesting on a text editor. We've got some Lua stuff. Client, functional. I guess these are like functional tests. Old and unit. What's in unit? Lots of good stuff, lots of tests. So I'm wondering if maybe the tests count for a lot of the Lua. I guess I'm not going to look at the tests so much. I don't know what snap is. Is it the Ubuntu snap thing? Yeah, it seems like some sort of configuration. And where is all the Vim scripts? Must be in here, right? Well, we have sh, should be shell. Ti, which might be whatever, tickle or something. And I don't see a whole lot here that looks like Vim scripts. We have .vim. Let me see if I can find some .vim files. I guess I should be able to see my command first. Oh, yeah. Okay, we've got quite a few files that are Vim script. 1,692. A lot of them are in the runtime auto load, runtime syntax, things like Groovy and Haskell. So these should be like syntax highlighting files are configured in Vim. Mutt, that's pretty interesting. Maxima and awk. There's a bunch of languages here that you don't think of as languages that would necessarily have first-class support. What if I get, yeah. Let me get rid of the syntax ones. Okay. We have things like tutor. I don't know what that is. Free basic. Maybe like I don't know, tar. Maybe these are like modes, like Emacs modes. And then colors. So the Vim scripts, they're kind of the same sort of stuff you would configure with in Emacs with Lisp. That's how I'll think about them. Things like nodes and like language syntax highlighting support. In the test directory, there was a vim/dir. Yeah, it might contain Vim scripts. I just closed the thing that told me where all the Vim scripts were, but there are lots of them. Hear that find command? Git/neovim/runtime is where a lot of them seem to be. All right. Enough dilly-dallying. Let's face the first code. So window, I'm going to guess, is fundamental. Vim.h might be like an important entry point header. Version, I don't think we care. User command, undo. I kind of am curious about the undo implementation. There's a UI compositor and a UI client and UI. Do we want to see the UI stuff? Let me know in the chat if that's worth looking at. Maybe terminal seems good. Tag might be support for things like C tags. Syntax defs and syntax, I guess. You know what? I'm going to look at strings just in case they have their own like wild string implementation and it's called something funny. So I don't spend the whole live stream, not realizing that some type is a string fundamentally. Okay, we just get string append. And I think that's basically it. Whatever our kvec is. If the string type is importing kvec, that might mean that kvec is important. Let's look at kvec. Klib. So we have a kb tree, a k hash, a k list, and a kvec. What is k for? K roundup. What is going on? We're going to decrement x and do some or equals. Then we're going to increment x. kv init, kv destroy. Huh. I don't know what this is. Attractive chaos. Let me try looking up klib. UI compositor might be interesting. Some interesting trees to balance windows, maybe. Okay, sure. I'll look at. I'll pull up a UI compositor. Whoops, this is just GitHub. I don't know why I clicked on it instinctively. I'll ask ChatGPT. Sometimes it knows about code bases. I can find. I'll say, what's the klib directory? It has things like kb tree and kvec, I think it was. Your ChatGPT knows about that. And then I'll open the UI compositor. Oops, I didn't want to go all the way back here. Was there another compositor I just saw? No, I guess not. Okay. So we'll look at the compositor header, and I guess the C. We'll just open the C file in case there's anything especially exciting in the C file. There's spelling, which I think we probably don't really need. I don't know what shada is. I guess I'll open it just in case. Search might be fun. Runtime is probably important. Regular expressions, maybe. I don't know. I don't know what an R buffer is. I guess I'll open a bunch of these headers and we'll see. Profile. Pause might be like position. P lines. Options Lua. I don't know if we care about options. Normal. Or normal move. Mouse. We'll ignore mouse. I don't know what a message is. Memory might be interesting. Mbyte. Math. Match. Mark tree is probably important. Mark defs. I guess I'll open the mark stuff. Mapping. I don't know. There's a lot here. Map defs, map. Oh, I guess we should have main and main. Let me open this in a new window. And I'll open main.c. Log, I'm going to ignore key codes. Yeah, sure. Is this the file that prevents you from quitting Vim if you don't know what you're doing? iconv indent. I guess I'm not. If you're a VI or Vim or Neovim user and there's like a file here that seems like you really want to see, let me know. it's not always easy for me to know, being unfamiliar with VI, what are the cool features. X, I don't know what X is. I guess let's open xcommands.lua and xeval. Might be interesting. And eval.lua. Yeah, so here's what I think as an Emacs user. I think the Vim people got jealous of Emacs's access to Lisp, and so they added Lua. Draw a line. I'm kind of curious about directed graph. I assume is what digraph is. Diff decoration provider might be interesting. Decoration debugger. I'm guessing this is support for debugging in Vim when you're a programmer, rather than debugging the Neovim codebase per se. Cursor might be important. Context, you never know with something like context. It could be like the most fundamental thing. Command history, I think that's going to be just some like listy data structure. But undo might, when we look at undo, it might tell us something about the history. Character set channel, I guess. Buff right. Buffer updates. Buffer. I don't know what a buffer is, but we'll open the header at least. Auto command. I'm not sure. I'll not look at it right now unless somebody tells me it's cool. Okay, so let me look at the chat. Jarvix, let me this is like a philosophical question. Let me get back to that in about 1 second. Yeah, we could look at the UI to look at the UI at terminfo.c. Yeah, okay. The TUI. Let me open this so that I don't forget. And I think X was mentioned as ed extended, so maybe a compat later. Yeah, so it might be a compat layer. That's a good guess. So, and then Jarvex is asking, what do you think AI like ChatGPT will impact the future of software development with the obvious replacement fear? It's a good question. People have all sorts of answers to it. I don't have a great answer to it. I have a lot of people around me who are more into the big trends than I am. And like when something like cryptocurrency comes along, yeah, buggy worm, philosophical answer. Yeah. You know, people who are like, oh, this is going to change the landscape of everything. I feel like I've seen so many different takes on the way that things are going to fundamentally transform everything else that I tend to have dampened expectations compared to at least a lot of people around me. So my take on AI is similarly a little bit dampened. I think it will have an impact. It won't necessarily be as immense or big as a lot of people think. But it will be big. So if you take something like cell phones or the internet, they eventually have a big impact. But what you see is, I think Bill Gates has this saying, or I don't know if he invented it, but I think I heard him say it once, that people like overestimate what you can do in like a week and underestimate what you can do in a year. And I think that sort of stuff also applies to things like AI. So people tend to kind of over predict the short run, but under predict the long run. And so we're going to see a lot of AI related startups. The first several many will probably be really bad, I think. And a lot of them are going to get their lunches eaten by Google, Microsoft, and Amazon. Just have so many more computers than everyone else and so much more data than everyone else that that it'll be easy for them to add features to things, like if you're an AI startup or whatever. And And as far as replacing software developers, it will replace some software developers for sure, eventually. But I think the most impactful thing it will do in the short run is enable top tier software developers to be even stronger through things like surfacing hard to find bugs, or like finding small optimizations that over the course of a year, running on thousands or hundreds of thousands of cores or whatever, will save millions or billions of dollars. So those sorts of things will I think we'll see them either they're ongoing now, or we'll see them very soon, and those will have a big impact. But it's not going to be like the sort of impact that you'll like read in the news, I think. And then 10, 15, 20 years from now, AI will just kind of be part of life. And a lot of the things that suck now will continue to suck. Will just suck with AI. But some things will be fundamentally different. And the things that are fundamentally different, I just don't think we have a way of figuring it out right now. I'm more worried about Bard replacing my internet troll job. Yeah, that's right. It's a good point. The biggest troll was Microsoft had an AI, right, that like started being super racist on Twitter or something. And then I don't know how involved Microsoft was with ChatGPT, but it kind of seems like whatever happened, they OpenAI trained ChatGPT on a bunch of stuff. People thought it was a nonprofit, and now it belongs to Microsoft. So I don't know if they intended that when they started out, but Microsoft seems to have won that round. Yeah, internet trolls for sure. We will see a whole lot of trolling with and like memeing with these things, if it's not already happening. I'm sure it is already happening. But somebody on the chat the other day was talking about elections in Turkey, and I don't know anything about the Turkey election situation. But if you're a person with a lot of money who's inclined to try to influence an election, hiring a bunch of kids and giving them ChatGPT and Midjourney or something to make memes is cheap and possibly effective. JavaScript will continue to suck with AI. That's right, Jarvix. And Semir, yeah, I agree. So man-machine symbiosis. Oops, I just bumped my thing, so hopefully that wasn't too loud. But so there's like we are way far afield of Neovim, but I think that's okay for a Friday. So I think Arthur Merlin protocol is maybe what I'm thinking. Oh, it's bye-bye? So there's this idea, so like interactive proof systems maybe is the right way to think about it. So we have these ideas that like, there's a formal or rigorous sense in which a person interacting with a computer as an interactive proof system is more powerful than, in some cases, I think is more powerful than just a proof system on its own. So I think we're going to get stuff like this, where it's the combination of an intelligent human and an intelligent AI. There's going to be a lot of interesting stuff that happens there. In like, you'll be able to prove more theorems in math, which means you get to understand physics better. And if you understand physics better, you can use that physics for things like chemistry and engineering. So we'll get like more interesting materials, more interesting energy solutions. I think all of that stuff will be really important. And then whether it replaces some JavaScript developers will be kind of like a rounding error in terms of like humanity. I think a lot of the people who are already on their career journey probably don't have to worry about being replaced by AI. But if you're like a kid deciding whether to code, you might have to worry about it. I think it's unknown. That's just my impression. I'm just rambling. Again, I've been awake since 3 o'clock in the morning. So so take that all with a grain of salt. But that's kind of where I am right now. And my mind is open if you feel like you have a good argument for why I should be more worried than I am, then I'm open to hear it. Okay. All right, so we opened some stuff in the TUI. We've got a parser for VimL, which I guess we probably don't need to look at. We have Lua. Let's see what's in Lua. Consider. Yeah, sure. Maybe the executor and whatever the converter is doing. Lib. And for lib, we get a queue and a ring buffer. I guess we've seen enough ring buffers and queues for now. OS should be maybe like, okay, so OS is things like probably file systems, file IO, input, PTY, signals. I guess we'll ignore this for now. And event, eval, and API. Let's just see what's in these directories. So events, we have a loop. Maybe this is the event loop. We have stuff with processes and streams and signals and sockets. And time. Yeah, I guess I'll open some of this stuff. I'm not sure how much I'll actually get to. This seems like a whole lot. What's an eval? Buffer. Oh, garbage collector. I guess we should look at the garbage collector. User functions. And did we look at API? Private command. So I'm guessing API is like if you want to like write a plugin for Vim. Actually, you know what? Should we look at the API first? I think I'm going to look at the API first, actually, because I'm guessing this will be the thing that you need to know if you want to extend Vim, or Neovim rather. And so with that in mind, a lot of people who watch this video are probably curious about this sort of thing. So just in the interests of making sure that we know what's going on a little bit as we look at everything else, let's open some of these files and take a look at them first. Did I open UI? Not sure. I'll open it again, I guess. Tab page, sure. Options, key sets, text mark, and I guess buffer, and auto command. Hi, Liman, and Sizik. Yeah. So Sizik, let me get back to this in about 1 second, and then Lima is saying, first time on the stream. Yeah, hi. There's a great talk from Joe Armstrong called "The Mess We're In: The Problems That Arise from so many programs doing basically the same thing." That's interesting. Let me I have a browser open here. Let me find that. Joe Armstrong. Is Joe Armstrong the guy from Green Day? Or is that Billy Joe? That's Billy Joe, I think. So I'll watch this this talk later. Thanks for the recommendation. At the same time, there will be a need for AI developers. Maybe the safest bet is research in CS. I don't know. You know, to be honest, I'm not the person. I'm not the person to ask. I just followed the stuff that I thought was interesting to me, and I have strong interest, so that wasn't hard to do. I was never the sort of person to try to like figure out where money will be and optimize my career in that sense. So I'm probably the wrong sort of person to ask about that. But I think no matter what happens, I think having a technical sense, like it, machines will continue to need to compute. So probably having the skills to have a background in CS is probably can never hurt you. Yeah. So okay. There's a lot going on here. All right. So let me get the Syzyx's question. Do I have any tips on how to read code effectively? I do, but none that I've really verbalized, I guess. Somebody asked me to do a tutorial on how I read code, which I will do. It's one of the things that's in the roulette for Fan Request. But just off the top of my head, I basically have an algorithm that I'm doing, which is a variant of like iterative deepening breadth first search. And I like to look at files. I think files are the unit of code that most programmers think about. So that's kind of why I'm doing things the way that I'm doing them. But a lot of the algorithm I'm using, I'm really relying on like domain knowledge that I have. And so when I'm looking at a more unfamiliar code base, it's more random. And when I'm looking at a code base where I have a better sense of what's going on, you'll usually see that I'll be like, well, I think that probably, this what's going on here is really about like these two data structures or algorithms, and I'll try to drill down to those, and then I'll just kind of consider everything else to be extraneous. So to do that, I think you have to have a sense of the fundamentals and the basics. But I will do a tutorial on how I read code. That's just kind of like a off the top of my dome, a few things that I've talked about before. There will be a need for AIs and stuff to save space. Yeah, I think research. I don't know. I feel like you should not go to research unless you love research, which I do. But even among people who love research, what I hear is that a lot of the so I have a PhD in math. My math advisor told me he had gone into math in like the 70s, and he told me that if he were a student today, he wouldn't have gone into research. So that's just one data point. Like I knew researchers at Google, and I obviously can't say anything really about the internals going on, but I can say that maybe that the sense I got was they, like in many companies, the researchers felt like they needed to prove that they had some way of generating income for the company. So that's not always a great place to be in, but certainly having the ability to do research, like being able to read papers and having done a little bit of research, I think is probably worthwhile. I don't know. And then you'll exaggerate things like this, but let me look at what you were saying. Yeah. Okay. I'm not sure exactly what you're saying, Lima, but one thing you might be saying when you say so many programs doing basically the same thing, one thing I am worried about with AI is kind of an outcropping of something I'm worried about already, which is with like user experience research and all of that sort of stuff. What people do is they make features, and then based on the average results of those features, that kind of determines the direction of the product. And so there's this averaging effect where everything gets increasingly targeted at an average. And I think that with AI, that'll kind of be the same thing. Like the AI will be tuned to the average. And so all the people who are different in some way and not average, they're going to increasingly be living in a world where stuff is automated for them, but it's automated for like the wrong person. It's like having a butler or something who's continually trying to do stuff that you don't want it to do. And I think that will be not only frustrating to people, but that'll also like, lead to worse like healthcare outcomes in some cases and stuff that really matters to folks as well. So I am kind of worried about that. So Samira is saying that they're curious about what data structures they use for text and also how they avoid copying. If there's an equivalent of string view or string pointers. Yeah, that's actually why I opened. That's why I opened the strings one. So I'll keep an eye out for that. It's not obvious to me yet where they do that. That might be in buffer or something. But I'll keep an eye out for how they do that. They probably do have something similar to a string view. We've seen similar things in other code bases, but I can't off the top of my head remember. Well, he is one of Joe Armstrong is. Oh, cool. I did not know that. Are we living in the golden age of computing? That's a good question. All right, cool. Yeah. Hopefully it'll be soon. And if it's not soon, I can record a like an offline version and upload it or something. Because I think that's worthwhile. At some point, I'll also have a website where I will have things like what the current list is and stuff like that. Because right now there's just nowhere for people to go and see that stuff. So Samir said, my manager is 2 PhDs in CS from Berkeley, 1 PhD from another UC school, said basically the same thing. 2 PhD. Yeah, you know what? Yeah, you know, I had a lot of fun doing my PhD, so I don't regret doing the PhD. But when I made a decision about what to do after the PhD, you know, my advisor saying like what he would have done played a role, and I guess it probably makes sense not to do if you're doing a CS PhD because you want to work in industry, then that's probably not a great trade-off. There are easier ways to get in. You know, I knew some people at Google who went in straight from undergrad and seemed to have a grasp on CS better than some of the CS PhDs I knew from good schools. And so it was clear that presumably he had just made the decision that instead of, you know, doing a PhD for like 5, 6, 7 years, he was going to spend the equivalent time at Google getting paid to learn, which I think is reasonable. Research day will never be like the old days of Park and Bell Labs. Yeah, I don't know. That's an interesting point, Bind. If you man, we are way down rabbit holes. I hope this is cool with people. But if you're into Bell Labs and research, there's a series by Hamming of Hamming distance and Hamming codes. This Richard Hamming lecture series, Learning to Learn, You and Your Research. I think these are all parts of the same lecture series. And he's really thought a lot about kind of the psychology of research and doing it well. And there's a little bit of jealousy for some of the other people. I forget who, maybe Tukey. Hamming seems a little bit jealous of Tukey, and maybe a little bit, what's the word? He kind of looks down his nose at one of the other guys whose name I forget. Famous name though. CS is the best you could go for since you have the technical skills. Yeah, I mean, CS is good. The convergence to averages is interesting. Feels like policy is kind of merging with implementation, and the convergence on the average is the new policy. Yeah, I think that's right. I think that's right. I don't know. I don't have a good way of how to change it. Maybe like dark CSS seems like a good direction, right? So now a lot of websites have dark CSS. Maybe there will be a thing where there's like a CSS for like I can change the UI to not be the average UI. Maybe I can change it to be a UI for people more like me, or you know, if you're, I don't know what sorts of things would influence what kind of profile you would have, but maybe that's one thing to do that. But then of course that requires everyone to know what sort of person you are. Yeah. Oh, is this nostalgia? Is this about Bark and Bell Labs? Yeah, that seems like it was a cool time. I don't know if anyone's doing that sort of research now. It seems like nowadays, I don't know what life was like at Bell Labs. Like if they felt like they needed to make money on all their research stuff. Because like the need to, since we're down rabbit holes anyway, well, I have a theory, and the theory is that a lot of the stuff that becomes practical started off as not having a real practical importance. So one example was number theory. For a while, the number theories were very proud that there was no practical application of number theory. And now we have things like cryptography. And I think that like the more you put pressure on research to produce like financial results, the more you're basically pruning a search tree in ways that you can't see, and you're kind of like over pruning it, and so you never search the space that has the treasure that would have funded the next 100 years of humanity or whatever. So I'm not sure that that's the case, but that's kind of the intuition I have. All right. So let's finally look at some code. How deep are we in now? We're an hour in. Okay. All right, let's go. So here's here's Vim.h. And there's not really anything here. We're just including some stuff, some generated headers, I guess. Here's Vim.c. And we're basically including everything. Wait, but this should be an API, right? There's nothing here that's an API. What's in Vim.c? We have some stuff about highlight groups and syntax check. Gets a highlight group by name. Similar to whatever this is. I guess this is, maybe these vertical bars are some sort of documentation thing that says that this is a symbol, but HLID is maybe the symbol. Get highlight ID by name. And we're going to return syncheck group of name data and name size. Okay. We can set some highlight groups. We can set input keys to NVim. This is a blocking call unlike NVim input. So NVim keys is going to take a string of keys, which are a string, a mode, maybe the mode that you're in, and a boolean about whether they're escape keys. The keys to be typed, behavior flags are the mode, and escape keys. If true, escape k special bytes in keys. This should be false if you already used NVim replace term codes. So by send keys, send input keys to NVim. So I think that we're in the API, right? So this is maybe like if you're an LSP server, or rather LSP client for NVim, and you want to have it type some stuff, you might send it as a bunch of keys in a mode. I don't know. Let's see what it does. Okay, here we have type buff. Maybe this is like insert into the type buffer, essentially to type it. We've got some stuff about remapping is dangerous. We're going to iterate over the mode size. And we're going to switch on the mode data. We have N, M, T, I, X, and exclamation mark. And I is insert. So this is the insert. This is like, is this like dangerous as in like quit when I do, what is it, bang Q? Is that dangerous mode or something like that? X is execute. I have no idea what the Vim modes are. Okay, so yeah, how modes are selected in work. Yeah, that's a good question. So first, let's find out what modes there are, which I'm sure many of you know, but let's just start with VI modes. And I'm going to look for an image because I don't want it to get like 700 blogs telling me about their life history and their history with Emacs, with Vim. So I guess VI is going to take a command. And if you press any of these things, I, capital I, A, big or a little O, you go into insert mode. If you press escape, you can enter a command. If you press colon, you go to the command line, and W takes you back to command, and quit will exit. Is that right? Let's try VI modes in Wikipedia. And maybe we'll search for insert. It operates either in insert mode or command mode, where keystrokes are interpreted as commands that control the edit session. For example, typing I in command mode switches the editor to insert mode, but typing I again puts an I in the document. Yeah? What does bang do? So Samira says if you you can do something like bang command and it will run in the outside environment. You can run 100%. Is that right? Okay. That's cool. Let's try it. Oh, what's it called? Nvim? What? Bang? Really? So if I press bang, it goes down here. Is that right? Oh, bang without the colon? What's a good command? How about echo? How do if I press exclamation mark, I get an exclamation mark down here. If I type, okay, so that is a shell. But I think I'm just, I don't know. I don't know how to get it to, but as I'm typing, things that I don't mean to type are showing up, but I'm sure there's some way to know what to, if you know what you're doing, to send a command to the shell that involves bang. Okay, so that sounds right. And then X is execute. Maybe execute what you're on the line of. At any rate, this is not the main way that modes are chosen. This is just for NVim keys, for NVim feed keys. I guess this seems like if you want to feed it keys from the outside, then it uses the switch statement. Is that right? If execute, save message scroll. So we're going to save message scroll, which is like save excursion, and then do some other stuff. All right, so queues raw user input. Unlike NVim feed keys, this is a low-level input buffer, and the call is non-blocking. I mean, is this? I'm not sure. I can't tell how fundamental this feed keys is. But let's just take a quick look, and then I think we're going to get to more of the internal stuff later. This should just be the API. Replaces terminal codes and key codes. NVim notify the user with a message. Okay. Gets paths contained in the runtime. Find files and runtime directories. This is array of. Oh, no, okay. So it's going to return an array of string, I guess is what this syntax means. This is just called nvim get runtime file. And we can get the runtime, a bunch of getters for like getting various things. Remove the global G variable. So nvim delvar with a name and probably error as an output parameter. And I guess it's been in the API since 1. In the dict, we're going to set a variable. I guess we have a global variable dictionary. We're going to set the name into the dictionary, whatever nil is. Oh, we're going to say, no, it's nil because we're deleting it, right? I guess that's, and then whatever true, false, and error are. Okay, so we've got another dictionary, get a V variable. What's the V variable? I have no idea, but we have another dictionary for it. Vim vardic is maybe var is more local, and Vim echo a message. Message was printed as a result of verbose option. We have outright writes a message to the Vim buffer, does not append new line. The message is buffered and won't display until a line feed is written. We can write an error as well. We can list the buffers, get the current list of buffer handles. So I'm guessing buffer is like an Emacs buffer, like a list of open file editing stuff. Oh, is this it? Should I be doing :ls bang? If I do :ls bang, oops. I feel like so Samir is saying, I'm guessing they'll execute commands car by car instead of parsing and validating the entire line command. Hence, they have to track a danger bit they see. Okay, that makes sense. So let me see how to execute shell commands in Neovim. Okay, so it wants me to put the bang in front of the command. Is that right? Yeah. Okay. So if I need to do colon and then bang, and then I can do like cat dev urandom or whatever. And it listens to control C. Okay, that's good. What is shell? Is shell a thing? What if I start Emacs in Vim? It just opens this. That's unsatisfying. What if I start Emacs with no window? I think it's that. Okay. So it's unhappy because the input's not a TTY, which is sensible. What if I start VI? Inappropriate ioctl for device. Okay. Cool. So it's calling out the shell if I do that. And that's probably why. So let's look at that bang thing again. But what if I do :I potato? Okay. So that doesn't go into insert mode. I was curious whether the thing after the colon was supposed to be the thing that we're switching on, but it's not. Okay. Fun times. Something about a callback. Find runtime. Oh, so, okay. So we have a callback. Do we have any interesting callback type? It's going to be a void star. Static void. It's going to take in a name. And I guess it's returning a cookie. I'm going to add star RV string object C stir to string F name. I don't know. So add is doing something. Okay. All right. How many more lines of code do we have here? Let's just kind of scroll through. We have env input, get color names, client info, get mark. Let's look at get mark. And again, we're in the API directory and not in like the low level guts. So delete mark is going to delete an uppercase file named mark. Fails with error if a lowercase or buffer local named mark is used. A file named mark. Inspect cell. Let's look at inspect cell. So if you have an integer grid, an integer row, an integer column, an arena, maybe for memory allocation, and I guess error is probably something we return. We're going to array dict init. And we've got this screen grid thing. And it should read from the compositor's buffer. The only problem is that it does not yet exist. Okay. And we're going to get, what's pumgrid? Whatever pumgrid is, we're going to get its handle. And, oh, okay. We're going to check if, we're going to check if grid is equal to whatever pumgrid is. Otherwise, if grid is bigger than 1, we're going to get a window by grid handle and do some validation. Whatever WP, okay, so the WP is the window pointer, I guess. Make sure it's not null. And something about alloc characters is not null. And maybe if the validation fails, we return. Otherwise, we set G to whatever the grid alloc thing is from WP. And we iterate over the rows. Oh, no, this is not an iteration. This is just checking some condition on the rows and columns. And if that condition passes or whatever, then we get, we're going to, I guess, probably allocate an arena array. And do some line offset stuff with rows and columns. Call add C with a string object. C-str must be C-string. I guess we're probably in C++. C-string is string. I'm going to call add C. Do some stuff with attributes. Add C again. And check some stuff with highlighting and return. So what's interesting here, to me at least, is the arena array. This should be doing something like allocating contiguous memory. I don't know if that's part of how they handle strings. And these functions like add C, and we've seen some other ones, they might be doing something interesting. I guess the first argument to add C is ret, which is the return of arena array. So add C might be a way of monkeying around with arenas, and in particular, putting strings in them. So I'm wondering if this is somehow what they use instead of something like a string view. Do they unit test for all the C voids, stars, and libraries? This is a good question. Oh, let me see. What did you? I wonder if they. Oh, okay. I think I saw that. Let's find out. So you mean like C string is, well, everywhere there's a void star. I don't know how you would know that quickly. I guess. We can spot check it. Where did we see a void star? Cookie. Find runtime CB. Let's just grab this and we'll just grep for this string recursively. And it doesn't seem like we have a test for find this runtime CB thing. What about for cookie? And let's grep for tests and the results. What's the thing? Maybe L? Okay. So files that mention cookie are that are also tests are, we have the syntax lit test, which this is not a syntax feature, so I'm guessing that's not so important. The helper's Lua. I guess we can look at helper's Lua. But I'm thinking they don't. I'm thinking that there are. They don't have Lua. There must be a Lua mode, right? Yeah, cookie equals nil. I don't think they do. I don't think they have unit tests for all the void stars. And I'm not even sure if their C string stuff is super tested. And Vim outright. Okay. Get proc and Vim error event. Okay. Yeah, I have no idea what's going on. However, I now have a hypothesis, I guess. So let's see if we can find out where add C is. And we also saw add. See if we can find where add C is defined. Do we think it's going to be like define? Something like that? Private. The private API is the place to be. Okay, so we've got object of O is O. I don't know where O came from. Add C is going to KV push C an item onto array. We saw KV. So KV push is probably pushing onto a KV vector, essentially. And add is the same thing without the C. What does KV push C? KV push P C. Maybe C string? Define KV push P C. We're going to take v.items and, oh, so v must be some sort of pointer. And we're going to add incremented by v.size. Yeah, and then that's push P. I guess that's like increment pointer. Then KV push C. It's going to increment the pointer and then set it equal to the thing that you passed in. Didn't I ask ChatGPT what was up with klib? And I don't think I ever saw what its response was. Let's see if we can find it. The klib directory in Neovim contains a set of lightweight, self-contained libraries that are used by various parts of the editor's codebase. Specifically, it contains, yeah, a balanced binary tree and a dynamic array, respectively. So it's a dynamic array implementation. Is that the idea? They just didn't have a better one to use back in the 1980s? Overall, it always makes me laugh that these overall paragraphs that add nothing. So how does, I'll ask, how does Vim VI avoid copying strings? Do they a special string? Would you call it shared string? I'll try that. What are macros saving here? Readability? Why did they make it a C macro? Could they just be functions? Yeah, they could be functions. And sorry, I missed a bunch of stuff. Why are they macros? I don't know, but macros, you get a couple of things. One is that they happen before compile time, right? Or they rather, they're like the first thing that happens. They should be. So they are, I guess we're in, I don't actually know what real gains you get from calling a function. Some of it might be efficiency. I'm not sure, like if there's extra function calling overhead that's not in the macros. I guess let's ask ChatGPT. And Rubicon is saying they applied to another job after a year of being unemployed. Oh, I'm sorry. I'm sorry to hear that, Rubicon. I hope you do not get another rejection. Yeah, that's sad. I think a lot of people are in a bad not a great or in a bad place right now. So I'm sorry to hear that. Us both. Okay, us. Yeah. I'm sorry, guys. I hope things turn around. I have a good feeling that we're like heading toward better times economically as a world. It seems like there were some indications of that. So I hope that's the case. So value and Vim, according to ChatGPT, use a shared string implementation to avoid copying strings. The implementation is called copy on write. Okay, it means that when a string is copied, the original string is not actually duplicated. Instead, both the original and the copy string point to the same memory location until one of them is modified. When one of the strings is modified, a new memory location is allocated for the modified string, and the other string continues to point to the original memory location. So they're going to use copy on write, according to ChatGPT. Okay, and then they use other optimization techniques such as lazy evaluation and caching. Okay, so I'll ask, where's the copy on write? So what file is the write string implementation? Can we locate it in? That's not a great. Oh, memline.c. Hey, thanks, ChatGPT. Okay, and then I'll ask Bard, when should I use macros in C or C++ instead of functions? So you get like metaprogramming stuff in C++ for doing kind of like type level polymorphism, you might say. I'm not sure if that's the right way to put it in C++, but you can have, you can get a kind of polymorphism where you essentially pass in the type. And in some cases in C, you get defines that are just basically constants, but like compile time constants, as opposed to runtime constants. And there are also some cases where you want to do things like you might do some like conditional something or other, and you want that condition evaluation to happen at compile time instead of runtime. But I don't think that covers all the cases. Okay, so when you need to perform a simple operation that can be easily expressed as a substitution, to define a constant or perform a bit shift, you need to perform a repetitive operation that would be tedious to write out as a function. I don't think that qualifies here. And when you need to perform an operation that is not supported by the language. For example, you might use a macro to implement a custom memory allocator or perform a floating point operation. They can be more difficult to debug. Macros are not type safe. They can be, yeah, maybe it's to support the resizing operation. Drop last n items from kvec without resizing. What about, is it called grow? I don't know. Oh, I'm in the header. Where's the non-header? These are all headers. Is there a kvec.c? Or it's all in the headers? I don't know. Maybe just because they can. If somebody knows why these are defined, the array, then let me know. I don't necessarily see any allocation stuff. X realloc. It seems like that could be a function. So Samir is saying maybe type general e. Oh, okay. A vector of int or char. The macros might help. Yeah, that's probably right. Yep. Yeah. That's a big case. That makes sense. So runtime check equivalent would be casting the void star. Macros are safer here. Yeah, that must be what it is. So there's no type information here. That's right. So we have kvec t. What is kvec t? So okay, yeah. Okay, so kvec t is going to take a type and it's going to emit a struct with size t, and type star of items. That's what it is. So if you pass in kvec of int, you get an int pointer. Thanks, Samyar. Samyar. Thank you. That sounds right to me. Okay. You see how we still haven't really looked at any code. All right, here's the ui.h, and there's not much here. Here's ui.c. I'll just see what sorts of things are here. We got pmap, mpack array. I don't know what m in mpack is, but we're packing something. We've got whatever a pmap is. We've got this macro for buffer position. Remote UI disconnected. So somehow we can interact with the remote UI. I don't know, over some channel. I don't know. I don't think it's like VNC. I'm not sure if it's like over, if it's just sending text over like a WebSocket sort of thing. Activates UI events on the channel and Vim UI attach. It's going to take a channel ID, a width, a height. Okay, the screen. I guess that's Vim, so you don't need to. Sending text is all you need, right? So, and options and error. Entry point of all UI clients. Allow embed to continue startup implies that the client is ready to show the UI. Very cool. If pmap has connected UIs and some error, UI is already attached to the channel. So whatever pmap is, it seems to be like a map that's going to record whether, maybe among other things, like the UI that are connected. You can set focus. Tells the NVim server if focus was gained or lost by the GUI. Okay, so when I click on another window, I guess we'll lose focus, and NVim will tell the remote server that it's lost focus, and similarly for getting focus, I guess. UI detach, you can detach the UI. You can try to resize, try resize grid. Tell NVim to resize a grid. Triggers a grid resize event with the requested grid size or the maximum size if it exceeds the limits. You can set bounds. You can flush events. Okay, that's good enough for me for UI. Nice, clever way to make a more general C type. General C type. Yeah, that's actually an interesting trick. When I joined Google, somebody recommended a book to me. I forget what it's called, but it's by like a madman, and it's like it's all like type level metaprogramming in C by a Russian guy. Unfortunately, I can't remember, so I don't know. I don't even know what to look up. A file-based channel. Yeah, maybe a pipe. I don't really know actually how pipes work, but let's see if we can find channel. It's an NVim channel. Oh, it's just channel.h, not a directory. Okay. Channel stream proc socket standard IO. Yeah, so we've got some standard IO stuff, but we've also got socket stuff. And then there might be an internal channel. And there's maybe RPC. And maybe a pipe, I guess. So it seems like all of these are on the table. And it might support all of them or some combination of all of them. Seems like client server where the server can be local and that seems right. The The server can be local, and you'd use AF Unix or remote. Yes, I think that's right. You mean the server can be local as opposed to you? When you say the server can be local, you mean it can either be local or remote. In which case, I think that's exactly what's going on. But I don't know. I don't know if you're always using a UI in that sense. Like, I don't know if I just start nvim, if it's always starting. I don't think it's like creating a local server necessarily, but I think I should be able to create one and then use it from another login or something, or just like connect to it as if I were remote, I would imagine. So here's window.h, which is nothing interesting. Here's window.c. This is going to be the window API. You can get the current buffer in a window. So it seems like windows have buffers, similar to Emacs maybe. Maybe this was a general way of talking about things, windows and buffers at the time. I guess Emacs has frames. So maybe I'm wrong. I set the current buffer in a window. So you can set a buffer, you can get a buffer. You can get the cursor, which will take a window, an error, which I guess just returns where the cursor is. An array of integer 2. 2 should be x and y, right? Gets the 1, 0 indexed buffer relative cursor position for a given window. Different windows showing the same buffer have independent cursor positions. Cool. But what if you have multiple cursors? Have you thought about that? nvim. You can set the cursor. Should we look at set cursor? Yeah, I guess so. Fine. First, so if we're going to set the cursor, first we're going to get the window from its handle. So we were passing a window, but this I guess is really just like an integer or something, some sort of thing that identifies a window. And then we're going to have to look it up in some data structure to get the real window type. This is probably some like C struct or whatever. And then we might not really have a window, in which case we bail out. And then we look at what position. We're setting the cursor to position. So if the position is not 2, position size. So it's a 2 tuple. But I guess it only the function only knows that it's like an array. And so we have to check the array size manually. And then we set the row and column variables from the positions so that we don't have to keep writing pos.items.0 or whatever. And we'll check that if the row is less than or equal to 0, that shouldn't be the case because we're indexing the row, right? Then we, I guess, error out if the columns is strictly less than 0 because we're 0 indexing the column. So it can validly be 0. Then we'll error out. Similarly, we'll check if it's too big or if the rows or columns are too big. Then we're going to set the cursor line number to the row cast as a line R type, line and R type. Similarly for the column, we'll set column add to 0. I don't know what column add is doing. When column is out of range, silently correct it. Okay, so I guess your function that's trying to set the pointer doesn't have to be too exact. So if you just run out of space, it'll just go to the end of the window, I guess. Make sure we stick in this column. Curse want is equal to true. Maybe that's for like overflow or like wrapping. If you have like wrapping set, I don't know. Make sure the cursor is in visible range with whatever switch win is. Maybe this is kind of like scroll to the cursor, update top line, validate cursor, restore window, redraw later. And then we're going to set the win W redraw status to true. So I guess redraw later is requesting like a graphics update event. Okay. And then we'll have more Windows stuff, but I think that gives us at least a flavor of what's going on with the Windows and cursors. Word kind of like Emacs versus Emacs client. Yeah, yeah, exactly. That's a good way to put it. We're translating everything into Emacs is how I'm getting through here. Um, all right, here's Vim Script.c. I'm not sure if there was a header, but so this is going to execute a Vim script, a multi-line block of X commands like anonymous source. Unlike nvim command, this function supports here docs, script scope, etc. Okay. Supports here docs. That's kind of fancy. So nvim exec2 will take a channel ID, a string source, I guess the source code, a dictionary of options, and it will possibly return an error, presumably. And this has been here since release 11. And we're going to allocate a result dictionary. I guess maybe the dictionary is some sort of viml object. And then we're going to just call exec implementation and then do some object checking and then return result. Here's exec implementation. Thankfully, it's right underneath and not in a totally other file. But what does it say about channel ID? Presumably, it's just where you execute it. It doesn't really say in the code comment. So exec implementation is going to take the same stuff and API object the Boolean. Look at ops output. This is doing something with ops. I guess deciding whether it should be output. And we're going to save message silent. I don't know what that is. And whatever capture GA is, or GA array, I have no idea. And then message column. And then capture local, maybe capture the local scope. Maybe this is capture global stuff. I don't know. And if we need to output, we're going to call GA init on capture local 180. Maybe 80 is the standard 80 terminal lines, terminal columns. And capture GA is going to be set to capture local. I don't know why, but we're going to call try start. And if we're supposed to output, I guess, then we're going to increment message silent and set message column to 0 to prevent leading spaces. We'll set maybe source context to channel ID and then do source string with source.data with the human readable string nvim exec2. I'm guessing do source string is like sourcing the file. So maybe it's, I don't know if it's just parsing or if it's like executing it. Then we'll check about output and maybe save some more GA stuff and some silent message stuff. We'll save the current S context, which I think I decided was probably source context. And then we'll try end, possibly, I guess, populating the error. Then we'll check if the error is set, in which case we have a goto, which is kind of interesting. And then we check more output stuff. And if we don't output, then we just return S. And the caller will free the memory. So what was S? Oh, I think this is still in the if statement. So string S is going to be, we're going to capture the local data, capture the local GA stuff, set them the data and size, and then check if the first entry of S.data is a new line. In which case we're going to move some stuff. And then we'll ultimately return S. It's the caller's job to free. And if we ended up going to the end, then we're possibly going to clear the capture local stuff and we're going to return string init. GA array, general type array? Yeah, it could be general. Let's do a search for GA array. Was it G array? Extern. Maybe define. What else could it be? A struct, maybe? Yeah, I'm not sure. I'm sure we could go deeper in finding this. Yeah, oh, sorry. Sorry, I read this as general type array. Like I thought general array type. Yeah, but what does general mean? We have capture GA, and capture GA seems to be in opposition to capture local. So my thinking is maybe it's global and local scope, and that maybe it's like global array type. Okay, so yeah, it could be a type def. No, I think I'm just extern globals. It's in globals. Let's see if we can find a G array. Oops, G array T. Capture GA, captured output for execute. Yeah, but where is it defined? That's what I want to know. Let's try grep in Emacs. Maybe things will pop out more. I think I set up God mode. Oh yeah, look at that. Okay. I don't know. Gap? There's a gap thing. GA clear, GA array type gap. Key map GA clear. I don't know. Types.h in the include. But what have I done? Where's types.h? Here. I don't know. Wait, we're in C, right? Do we have C tags? What is it for recursive? C tags something recursive? C tags capital R? Thank you. What? I don't know if I have like a different C tags thing. Or maybe it's supposed to be C tag. Is it C tags E? R is recursive. No, R is regular expression. Let's try C tags E. It didn't, that didn't seem too fast. I don't know. C scope. Okay. Do I add an R here? Then C scope. I don't know if I have C scope. Just try install. Decal versus definition. I don't even remember what we were searching for. So let me try this C scope thing. What? Oh, it's okay. EQK, and then we were searching for what? G array type, maybe with no source files found. I don't know the C scope syntax. I could try L1. What if I just search for kvec? I don't know what C scope is doing. Oh, do I have to generate C scope stuff? Okay, so do I have a C scope out file? Do I just pass it like that? Yeah, look at that. But I want a G array type, right? I don't know. A second. Okay, so it found kvec. So it seems like int. Right. It's just garray.h. All right. So that was maybe not the most engaging content, but at least now we have better search. Okay, structure used for growing array. Maybe it means growing array. This is used to store information that only grows, is deleted all at once, or needs to be accessed by index. See GA clear or GA grow. So it's an append-only array, like the Bitcoin database. Samir, I'm glad that I'm not the only one who wasted my time trying to figure out where this thing was, and it was just called garray.h. I think that's sometimes stuff is like that, especially when you've been up since 3, like I have. Okay, so garray is growing array. I don't know what capture local is, but I guess the capture growing array, which I'm going to think of as a Bitcoin blockchain, because it's append only, and And then there's something about local. UI events, I'm just going to totally ignore because we've been here for a while and we've seen some of the API already. I think we have a little bit of a flavor of the API. Here's the UI. I guess I will look at this. We've got some impact stuff. In PMAP, I think we just saw this, right? Unless they're redefining all of this. Wait for it. Remote wait for attach. UI attach. I think we saw UI. Tab page. The header, again, is not useful. Options header is not useful. Key sets. .h. You've got these huge structs on start, on buff, on win. So these are like events that I guess you can be called for. ID, end row, vert text, highlight, end of line, highlight mode, priority, end right gravity. I'm not sure what gravity is for. Maybe something typesetting style. No remap, no wait, silent. We've got these many large structs. Address, bang, bar, complete, count, force, keep script. This is key sets. I guess these are things that you can do that you can assign key codes to. Like bold, strike through. I'm not sure. I think in Emacs you can, everything's a function and you can assign key codes to it. So I haven't really thought about if you're not in Lisp, maybe you have to have a type that's the type of stuff you can assign a key code to, because it might have to have like a hook or something. Not sure. Makes me just code search. Yeah, code search is good. I mean, even just having a sensible Emacs, a sensible Emacs config would save some of this. What I was always saying is that once we started looking at the LSP stuff, I would hook up an LSP server, which I will do. But then I tried to do that yesterday, and I ran into some troubles that were, I think, geeks related rather than were the fault of the LSP servers or anything. But so I just have to get that set up. But for those who have been waiting, we're entering the zone of having better interface to code. I'm also I think next week looking at source graph, which it seems like it's trying to be kind of like code search for the outside world, although I don't know enough about it. But I'm hoping that's what they're trying to do, and that it will be a suitable replacement. So the rest of these headers I'm just going to ignore because maybe buffer. No, okay. Whatever auto command is. Okay, so that's the API. I feel like that was worth our time because we got a little bit of understanding about what's going on in Neovim. But now we are maybe heading into the deeper implementation. Let me check something. All right, cool. I don't know where I want to be next. So we have event eval, API we already looked at, loop. This should be something like an event loop, right? Create event, which is a define. It's actually kind of interesting. We're gonna take a multiqueue and a handler and then some argc and ... And we're gonna emit do if multiqueue put, multiqueue handler, blah, 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 else void argv. If we do have a multiqueue, we're gonna emit like multiqueue put essentially. But if we don't, we're gonna index into the variable arguments with argc. And I guess it's void star. I don't know what this is, underscore underscore va args. Maybe that's accessing the stuff that was passed in here. And then we're calling handler, the handler function, I guess, on argv, which is passed in here, while 0. So this stuff seems like type programming. So argv is not passed in. Is argv the same argv that main has access to? I don't know. But it seems like this is a way of creating, of having a handler being called on some arguments without specifying what the arity of those of the function is in the type. And then multiqueue put, I'm not sure, maybe multiqueue maybe either has multiple queues or maybe it does multiple, it allows multiple types. We've got this loop struct with a UV. I don't know what that is, but also it has two multi-queues, one of events and one of thread events. And also some fast events. Immediate events processed after exiting UV run to avoid recursion, but before returning from loop poll events. The practical consequence for main loop, these events are processed by state enter .os incar, whereas regular events are processed by state enter .vim state.execute. And I guess we keep track of people who are watching, used by bot process and job control subsystems. And the children watcher, which sounds a little bit creepy. And children kill timer, which sounds much creepier still. And then we have a generic timer, which is a poll timer, and exit delay timer, and whatever async type is. But we've also got a mutex and int recursive, maybe keeping track of how deep you are in the recursion. And then, yeah, that's a loop. That's kind of interesting. And we're going to klist init watch pointer stuff. I feel like LSP is the wrong approach. Okay, so Samir is saying, so Samir is also a former Googler. And he's saying, I feel like LSP is the wrong approach. If you use a protobuf, an LSP will only catch one language. And you end up needing to do a regex search anyway. I see. Yeah, okay. I guess I would assume something like SourceGraph works by, I have no idea, but the way I guess that I would expect it to be built is if you have a repo with multiple languages, yeah, I don't know. You could imagine it has a different LSP backend for each language. And then when you do a search, it would search all of those backends. And maybe you could also specify a restriction to one language, but I don't know. Also, LSP contributes to documentation getting stale because it doesn't get passed to the compiler. So what do you mean when you say it doesn't get passed to the compiler? What's not getting passed? If you use a protobuf. Oh, I see. Yeah, so if you have something like a protobuf where you wouldn't get literally the same symbol in a bunch of languages because each language might have an idiomatic transformation of that symbol. But you would want to be able to say, like, show me, if I have protobuf, I have the bookshelf proto, and I have this books message. I would like to see all the Python code that has the message thing and all the Java code that has the message thing. And so there needs to be something that translates, I guess, protos into the respective symbols. And so that's a layer that's deeper than just searching all of the search engines at once. Is that the sort of thing you're saying, Samir? In which case, I think you're right. And basically, so that's code generation. So it would have to maybe be code generation aware in general. Yeah, that's a good point. So poll for events until a condition is, so far we haven't looked at anything mono repo-ish. where there's more than one language. I don't think. Unless you want to count Lua and Vim L and C and that sort of stuff. Loop process events. Yeah, so this is all, these are all like macros or defines or whatever the official term is. The loop process event is going to take a loop and a multiqueue and a timeout. And we're just making sure that we have a multiqueue and it's not empty. And in which case we call multiqueue process events on the multiqueue without the loop or the timeout. Otherwise, we call loop poll events. And I guess this loop is going to pull some stuff with a timeout. And so this else condition is like a poor man's multi-queue or whatever. Seems like, which is kind of interesting. I don't know. Maybe this is to support environments that are less fancy, like small VMs, like I was talking about before. Here's socket. I don't think we need to look at socket closely. Signal. What signal header? Got a signal watcher. And we still have this UV thing. I don't know what UV is, but we get signal callbacks, close callback, and some more multi-queue stuff. So this is all event stuff. Are these all events? Here's a val and user function. I'm going to get out of events, but I am curious about a val. I think we have a ton more stuff open. So here's garbage collection header. And we've got some sort of dict. That's the GC first dict in the GC first list. And we're including the generated code. Here's the GC implementation, and it's doing nothing. Head of the list of all dictionaries. GC first dict. Okay. So we're going to, for all dictionaries, I guess, we're going to store the heads of the dictionaries in this garbage collection list, this first dict. And similarly for the head of all lists in this first list dict. And then I guess that's just going to make it easier for the garbage collector to walk all of the dictionaries and all the lists. But this doesn't actually seem to be, this is garbage collection for eval, but where is anything actually collecting the garbage? Maybe let's try searching again. Where am I? I don't think this is the C-scope one. We have gc.c and whatever. Maybe we try first list. Yeah, I don't know. First dict. I don't know why it's not finding that. What if I change 1 to 2? I don't know what the L does. Okay, so it doesn't seem to be finding the first dict thing for whatever reason. But I guess I can just grep for it, right? It's in eval GC, it's in type val, and it's in eval. But I don't know where it actually gets collected. Garbage collection can only take place if you're sure. May collect garbage is equal to false. Garbage collect. Oh, maybe this is for Lua. Maybe it's in the Lua stuff, which would make sense since it's in eval. So I guess that eval.c is like a C world place where maybe the Lua stuff, we keep track of the Lua stuff, and somehow in the Lua code, we're going to garbage collect stuff, perhaps. That'll be my working theory. Here's eval/user func. From user function to hash item and back. So we have some user function, and I guess we can turn it into a hash item, probably for putting it into a hash table. I don't know what a UF flag is. Structure used by trans function names. We're going to get a dictionary and some stuff with allocated memory. I guess we're taking user functions and putting them in a dictionary and possibly calling them. And this is, I guess, if it's in eval, it might be for either Lua or Vim, the Vim script thing, VimL. I don't know. And there might be errors, such as too many, too few, script, dict, other, deleted, or not method. The function cannot be used as a method. Use a structure passed between functions dealing with function call execution. F-E-arg-func, when not null, can be used to fill in arguments only. I guess we'll keep track of the first line and last line of a range. Does range. Evaluate partial self-dict base T. And func exe init. It's just going to set all this stuff to null or false, basically the 0 version. Okay. So we've got some support. We've got some support for having functions. But I'm not sure exactly where it's used. Maybe probably in one of the scripting languages. And we wanted to see strings, right? Let's see if we can find strings. Strings.c. Okay, so string save, copy up the length bytes of string into newly allocated memory and terminate with a null. The allocated memory always has size length plus 1, even when string is shorter. Okay. We can string save escaped ext. Same as string save escaped, but when BSL is true, also escaped characters. When rem backslash would remove the backslash. Save a copy of an unquoted string. Turns a string like this into whatever this is. For use in shell build varg. This should be copy on write, right? Let's see if we can find copy. Replace. I'm not seeing any maybe this is where I'm supposed to be. This is a massive function. Print f. So this is some right formatted string value to the string. So this is like a printf implementation. Adding stuff to sprintf, I guess. TV pointer. Get pointer argument to the next entry in TVs. We'll give an error message for VimL entry with invalid type or for an insufficient entries. TV string. Get string argument from IDXB entry in TVs. I don't know what that is. We have multi-byte strings, compare two strings. These are just const char stars. I don't know why they have their own implementations for this stuff. Maybe it predates some of the other stuff. String case save, make given string all uppercase or all lowercase. There's some interesting stuff in here. I bet that Vim users use this sort of, set it to uppercase or whatever. String save, save a copy of an unquoted string. Maybe I do want to look at this. So, okay, so I fact checked myself. LSB as a protocol and its interface, LSIP, allows symbol lookups beyond language. Okay, LSB implementers just typically don't implement it. Sad. Okay, yeah, that makes sense. Beyond the language. Oh, okay. So each language could be aware of. You could pass in like a proto thing, and in theory, you could be able to look up. If you were the Python LSP implementation, and you could take a proto symbol and return the Python matches, and then each LSP server would have to implement that independently. Maybe is that the sort of thing you're saying? I think that would make sense. Let's look at the save function just to see if it's doing anything interesting. It's doing the unquote stuff, which is not so interesting. And we're just x-mallocing some stuff. Yeah, I don't know. I don't see anything that looks like it's deliberately copy on write, but it could be kind of in all of this stuff, and I would have to really dig into it to figure it out, which I'm not so inclined to do. Mem move kvec string builder. We have a string builder, which is kvec type. We have string append string to string and return pointer to the next byte. Let's look up the internet, see what the internet knows. Copy on write. Wait a minute. DuckDuckGo is ignoring like all of my search terms. I'm not sure. I don't see anything quickly. Maybe we'll run into it. Here's Vim.h. It's just like the first thing we opened. Okay, so here's Vim.h. This is the header, not of the API, but of the mvim directory. And I'm not expecting it to be too interesting. Although we have mode normal, mode visual. So here are the modes. Values for state. The lower bits up to OX80 are used to distinguish normal, visual, OP, pending, command, line, insert, replace, terminal mode. This is used for mapping. If none of these bits are set, no mapping is done. See the comment above do map. The upper bits are used to distinguish between other states and variants of the base modes. So mode normal is OX01, normal mode, command expected. Then we have visual mode, use get real state, and mode op pending. Normal mode operation is pending. The command line mode is editing the command line. Insert is insert in mode, also for replace mode. Then we have lang map, language mapping, select mode, terminal mode, map all modes, and some replace stuff, replace flag, mode replace, mode normal busy. I guess normal mode, but we're busy with a command. Hit return, waiting for return or command. Ask more, set W size, extern command, show match, and confirm. All right. Probably should have looked at this a while ago. All right, and then we've got some enum of forward, backward, forward file, backward file. I guess maybe this is the direction we're editing in or moving in some sense. Return values for functions. Okay, fail, or not done. Not okay or fail, but skipped. Okay, and then we have values for type. type number, type string, type func, dict, float, special. Then we have a giant enum. Values for XP context when doing command line completion. So when we're doing command line completion, I guess XP is expand. And so we can get OK or nothing. But also things like directories, bool settings, menus, syntax, highlight, functions, language. I have no idea what all these enums, this enum is being used for. Pack add, own syntax locales. It's kind of seeming like flags. But I don't know if these are like mutually exclusive. And then we get some constants like swap page size, clear field, clear pointer, and some other stuff. Here's window.h. Values for file name inline. Okay, so in window we're getting some stuff like that seems to be for messages. So like maybe like showing the file name, path, file name include, apply include expression. And we have the relative file name. Arguments for win split. I guess if you want to split stuff, we have win split room, win split vertical, horizontal, top, bottom, below, help, new, loc. And we're just getting the constants in the header. Here's user command. The user command is a struct, which has the command of the name, an argument type, a replacement string, maybe for like regex stuff, a default value for a range or a count, a completion type, the command's address type, where the command was defined, source context, I guess. So like where in the source code the command was, completion argument, if any, and some Lua stuff, reference to Lua completion function, Lua preview function, and reference to Lua function. And that's really all that's here. And then we have this grow array of U commands. So I guess since it's a grow array, and if I understand a grow array correctly, we're either going to delete them all at once or we're never going to delete them. And then we have this macro user command, which is just going to basically add to the data. Here's undo, and there's nothing interesting here, but maybe in undo.c there is. So my question with undo is always like, I'm always curious how implementing undo is hard, because you can't undo an operation. You really have two options. One is to like always store the state in some sense. And the other is to store some sort of transformation, but that transformation needs to have an inverse, or you have no hope of undoing it. Like you can't have something that loses information. If you want to undo an operation that loses information, you better have stored the state of all the information before, or maybe just like a diff. So I'm just kind of curious what they do. The saved lines are stored, multi-level undo facility. The saved lines are stored in a list of lists, one for each buffer. We have the old head and the new head. Wait, what? So is this the beginning? We have a U header, next, previous. Okay, so next is null, and that's the head. And then here, previous is null, and that's the new head. So the old head has no next. The new head has no previous, no predecessor. And then there's an entry, I guess, and these are the entries. And each entry has a pointer to a list. Okay, so down the rows we get entries, and across the columns we have headers. Each uEntry list contains the information for one undo or redo. Curbuff bu curhead points to the header of the last undo, the next redo, or is null if nothing has been done, end of branch. For keeping alternate undo redo branches, the alt field is used. Thus, at each point in the list, a branch manager may appear for an alternate to redo. The usec field is numbered sequentially to be able to find a newer or older branch. right? Something about alts. All data is allocated and will be freed when the buffer is unloaded. Uncomment the next line for including the ucheck function. This warns for errors in the debug information. Turn on debug by uncommenting a line. We have some magic stuff. Value for magic when in use. I'm in the C file, right? But what are we storing? So check tree. So yeah, we've got a tree, and we're gonna give it the header. uheader t for the UHP and the exp u next, and the exp u alt previous. And if we're null, we're gonna return. We're gonna increment the header count, and check the current head, and increment scene buff current head. Oh no, this is an if statement, and I guess this means that we may have found a cycle because we've seen cur head twice. And then here's some more error checking. We're checking magic, and if the magic is wrong, you might accidentally be using freed memory. It's bad. And then if everything checks out, I guess we're gonna check pointers. Check pointers back are correct. Okay, so check that the UHP pointer next is not equal to the USP UH next. And then we do some more stuff like that, and then we recursively call check tree on our children, I guess. And then we have this ucheck function. But yeah, what I know, I think what I want to save the lines between top and bottom for both the U and the lowercase u and capital U command. Top may be 0 and bottom may be curbuff b m blah 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 +1. Careful. Matrix or auto commands that reload the buffer. Returns fail when lines cannot be saved. So I guess we're giving a line, top and bottom line, doing some checking. If top +2 is the bottom, then we're just calling save line on linear type +1. Otherwise, we're calling save common. What is save common doing? Save common is common code for various ways to save text before a change. Top is the line above the first changed line. Bot is the line below the last changed line. New bot is the new bottom line. Use 0 when not known. Reload is true when saving for a buffer reload. So it seems like we're just really saving the text rather than saving the operations, which would make sense. And that's really all I wanted to know. Here's terminal.h. And we're just keeping track of a width and height, some callbacks for resizing, for writing, and for closing. And we've got these void functions to write. Yeah, okay, it's just type defing the callbacks and stuff. That's not so advanced. Here's tag. Do tag. The tags are things like jump to new position, jump to older position. This seems like support for go-tos. DT jump, DTL tag. Let's look up VI tag. There's a struct for tags. Tag F name. Enhanced tags. Exuberant C tags. So I guess this is for like C tags, is that right? Jump to first match of same tag, jump to first match of same tag. I guess this is for navigating with tags, but these like defines are for what kind of operation Vim should do. Jump to older position. Like you might want to navigate back and forth with respect to tags. And this is, I guess, for keeping track of that sort of stuff. Syntax definitions. We have some structs, sp syntax, sp, I don't know, but it has an inc tag, include unique tag, highlight group ID of item. So I guess for a given item, there's an identifier. What is it identifying? It's identifying a highlight group. And the highlight group presumably knows things about like what's highlighted or what color it is. And cont in list. Cont in group IDs of 0. I don't know what cont in. We have a key entry. Each keyword has a key entry, which is in a hash list. And a buffer state to store one state of the state stack. It has index of pattern, flags for pattern, whatever SI sequence number is, SI car, and the syntax state, which is a next align number, and a union of SS stack and SS grow array, next flag stack size, and a disp tick. Shouldn't there be like a regex? RG? Somewhere there's regexes. We're certainly including them. Maybe there's a C file here. Maybe there's a CC file here. Maybe there's not. Syntax.c. Syntax.h. HL, I guess, is highlight. We have HL contained, transp, one line, has end of line, sync here, sync point after this item. I don't know what syncing is for, but skip white space, I guess, keep end display. This looks like highlight relevant stuff. But this, I want to see this, maybe see the C file for. Okay, here's maybe the struct that I wanted. So syn pattern. The patterns that are being searched for are stored in a syn pattern. A match item consists of one pattern. A start end item consists of n start patterns and m end patterns. A start skip end item consists of n start patterns, one skip pattern, and m end patterns. For the latter two, the patterns are always consecutive. A character offset can be given for the matched text and for the actually highlighted text. Okay, so we have a type, something for syncing, and down here we have like a reg expression to match. And so this should be basically how they do syntax highlighting, is you have some regular expressions that are in some struct, which might have offsets. And if you want to implement syntax highlighting for a language, you have to have all the regular expressions to figure out how to parse things. At least that's what I think. We already looked at strings.h. Here's UI compositor. Somebody asked for a long time ago. Here's the header. There's nothing interesting in the header. And in the C file, we've got things like buff size, align buffer, attribute buffer. We've got this UI comp init. We're going to kv push the default grid, I think, onto the layers array or vector, if I remember how kv push worked. And then we're going to set the cur grid to the default grid. Okay, so whatever was in default grid, we're basically saving it in layers. And then we're going to select the default grid as the current. Whatever syn in it, maybe sync in it, syntax in it. And we have normal, clear, composed, recompose. And we're going to call syncheck group on stuff. Redraw, debug normal, debug clear. Okay. And then UI comp attach. When you go to UI, we're going to increment composed UIs. We're just giving, and then we're just going to set UI composed to true. And when we're detached, presumably we're going to decrement it, possibly free it, and clear it, and set it to false. Here's something about whether we should draw. If we have composed UIs and if we have non-zero composed UIs and a valid screen, then I guess we should draw. And some here are saying, it looks like the subsystem that identifies syntax also gets used by the tag lookup. Makes sense. I think I missed that. Or maybe I didn't notice that. Which would make sense because they're both basically doing more or less the same thing. They're identifying parts of like a programming language to either highlight them and or enable you to look them up, I guess. Now here's comp put grid, places a grid at column row position with width, height, size, adds grid to the top layer. So is this what it means by compositing? It's just going to be a grid mode? I guess that's a sensible definition of compositing. I don't know what else you could do. Yeah, I'm gonna guess that this is really what's going on. That by compositing it means just having like multiple terminals or files in a grid. So you've got a height and width, and checking some stuff about the grid index moved. Okay, so he places a grid at column row, position with height sides, adds grid as the top layer if it is a new layer. We might have moved. If we should draw, we draw the area covered by the old position and is not covered by the new position, disable the grid so that the composed area will not use it. So I guess we'll disable grid comp stuff, then call compose, which is presumably just going to do basic math to figure out which things are including which other things. And since we're only looking at rectangles, that's not difficult. And then we're going to do some more rectangle-y math, I assume. And then eventually we might insert some layers. And we're going to look at the size of layers using this kv macro thingy. And that'll tell us where to insert, I guess, if we're at the end. I'll insert out is bigger than 0 and kva of layers inserted blah, blah, blah. We're going to insert minus, minus. Okay, so this is just some algorithm to figure out where to put the window. We'll look at the current window and I guess maybe check whether we're on top and also maybe insert minus, minus. Not found, new grid. I guess if we don't find what we're looking for, we'll create a new grid or something. And if we moved and did some other stuff, we'll call compose area and we'll return moved. We can raise grid, comp grid cursor go to. I guess the go to is going to take a grid handle, an integer R and an integer C, I guess row and column. We'll check if we should draw. I guess if we shouldn't draw, and we can't set the grid to the grid handle, then we'll return. We basically failed, but we're not returning any sort of error. And then we're going to get the row and column. And if the current grid is not the default grid, then we'll do some stuff. I guess we'll try to find it. May not be the best time to do this. For efficiency, we should configure all grids before entering Win update. So we're going to use some sort of searching with grid if we're not the current grid. And then look up cursor stuff. And then UI composed call grid cursor go to. And this is some implementation function. We've got stuff for mouse focus. You can compose line, baseline implementation. This is always correct, but we can sometimes do something more efficient. So a composed line is going to take a row, a start column, an end column, and some flags. And there's a big algorithm for this, which is, I'm sure, probably pretty interesting. but since I'm so tired and I've been here nearly 3 hours, I'm not going to look much deeper into it. I still have no idea what SHADA is. SHADA read file. I guess I'm not going to care. Search might be interesting. Oh, this is probably just like find in the buffer. So search reverse echo the search command, search message. Search history. Okay, so this is just support for various search things. Structure containing offset definition of the last search pattern. SPAT. Structure containing last search pattern. And so SPAT must be search pattern. So we'll take a pattern, which is a car star. I'm not sure if it's a regular expression or just like a more general pattern, or more, I don't know if it's more general or more specific. Some magicness of the pattern, whatever that is. Whether there's no smart case, a timestamp of the last change, a search offset, and additional data. Okay. There's a pattern. I don't know what magic is. This is basically an option. Pattern offset. I'm not sure how that's used. And I don't know why we need a timestamp. But I'm sure there's a reason. And then optional extra arguments. Maybe, I think in Vim, once you search, you go into like a searchy mode and you can keep like finding the next thing. So maybe the timestamp is for keeping track of if the file changes while you're in that search mode, perhaps. Then we have a fuzzy matched string list item used for fuzzy match completion. Items are usually stored by score. The IDX member is for stable stored. We have an index string and a score. And then I guess as we're fuzzy searching, we're going to change the score. I guess I'm mildly curious about the fuzzy search. Because the windows, so Samir is saying because the windows can't really overlap like a windowing system, they can just use rectangles and assign rectangles based on some height width. Yeah, I think that's right. When I was saying they're just doing rectangles, I was saying that in the context, I guess, of like on this channel, we've looked at a few things like game engines and React and Flutter. So there you have to basically be able to draw, like in a game engine, you have to be able to possibly composite general three-dimensional shapes or two-dimensional shapes. I don't know if it's called compositing in 3D or whatever, but and so there's more. It's just a little bit harder to figure out, like if a cone intersects a sphere or something. So I was just saying, I was thinking it's just rectangles because it's like a special, much simpler case of some of the sort of logic we've seen before. But it probably is true that they can't overlap. There's not going to be like, you're not going to be like missing a corner out of one of your terminal things. I don't think. Maybe. But yeah, I think that's right. So it's even simpler than just any old rectangles. Here's search.c. I think I had a reason I was looking at this. Oh, yeah, I wanted to see the fuzzy matching. Fuzzy string matching. So it's going to be ported from libfts, authored by Forrest Smith. I've noticed often when I look at a piece of code and I'm like, you know what? I realize I have no idea how to implement string matching. Very often, what I find is that the implementation is from some other thing that specialized in this. In this case, whatever libfts is, I guess it has some sort of fuzzy text search. And so I think very sensibly the Neovim authors or the Vim authors or whoever this originally came from are using somebody else's implementation. Each matching string is assigned a score. The following factors are checked: matched letter, unmatched letter, consecutively matched letters, proximity to start, letter following a separator like space or underscore, and uppercase letter following lowercase. Matched letters are good. Unmatched letters are bad. Matching near the start is good. Matching the first letter in the middle of a phrase is good. Matching the uppercase letters in camel case entries is good. The score assigned for each factor is explained below. File paths are different from file names. File extensions may be ignored. Single words are about consecutive matches, but not separators or camel case. The score starts at 100. That's supposed to be like a normal distribution. So we're going to start centered on something. And because we can't start at 0, I guess, if we were using ints or something or whatever. So a matched letter is plus 0 points. So no bonus and no penalty. An unmatched letter, there's a penalty of a single point. If we've matched consecutive things, there's a bonus of 15 points. The first letter bonus gets 15 points. I guess matching the first letter of a word. A separator bonus gets 30. Gets a bonus of 30. Camel case bonus is 30. Unmatched leading letter is -5, down to -15. There's some nuance to this. Scores don't have an intrinsic meaning. The score range isn't 0 to 100. It's roughly between 50 and 150. Longer words have a lower minimum score due to unmatched letter penalty. Longer search patterns have a higher maximum score due to match bonuses. Separator and camel case bonus is worth a lot. Consecutive matches are worth quite a bit. There is a penalty if you don't match the first 3 letters, which effectively rewards matching near the start. Okay. There's no explicit bonus for an exact match. That's actually really interesting. Now I know slightly more about fuzzy search. Okay, here's runtime at h. I don't know. I have no intuitions of what it's going to need for a runtime. But we've got something that says e-type. We have e-type script. We have script user function, auto command, mode line, exception, arguments, environment variable, internal, spell file, loading spell file. Are these like different states it can be in as it's doing work? I'm not sure. And we have execution stack. We have ESLNum, ESName, ESType, source context, user function auto command, and exception info. ESType source command. I don't know. I don't know what this is. Script and mode line info. So something about scripts and mode lines. I guess this is for executing different stuff. Oh, this is a union. So it's either we're either executing something from a script and or the mode line, or we're executing a user function. We're executing whatever an auto command is, and then or we're doing some exception info stuff. And we've got a line number associated with it. And here's a stack of execution contexts, and it's a grow array. And the arguments for eStack are sfile, stack, script. I don't know what those are about. We have a hash table with variables local to each sourced script. Okay, so when you have a script and it's processing it or sourcing it, it's going to keep track of the variables in that script in a hash table. Each item holds a variable, nameless, that points to the dict. So we've got some scope dict item and an svdict. And then we have a big struct, which stores variables for the script, whether profiling is on, time set when going into first child, nesting for SNPR child, time spent in script and children. So some of this seems to be like a lot of profiling stuff. Start time. Maybe this is all profiling. Script item. Well, not all of it, but the variables, the name, etc. are not profiling. And then a lot of stuff seems to be about timing and profiling. And then we have a runtime search path and some stuff about Lua. All right. Here's runtime.c, which I'm going to ignore. Regular expression, I'm going to ignore. Our buffer is a ring buffer, basically an array that wraps read-write pointers around the memory region. It should be more efficient than the old R buffer, which required mmove calls to relocate read-write positions. I'm not going to look at ring buffer. For profile, I'm just kind of curious what a profile is supposed to be. But there's nothing here. Is there a C file? You know what? Profile is probably going to be profiling. And in fact, I see elapsed time. So profiling in the sense of like how long do things take? Are they efficient? Here's pause. And this is going to be stuff like the line number type, which we've seen all over the place. And other such stuff. The position is line number and column number. Makes sense? P lines? I have no idea. Start of line, pointer lines? I don't know. Verge text. Not sure what that's going on. Normal? Is this normal mode? Values for find ident under cursor. Find ident. This is for finding an identifier, finding a string, finding eval. Includes this pointer or right arrow glyph and the okay, find eval. So this is for looking for syntax that evaluates like a function. So I guess this this might cause a function evaluation. This would be like an array lookup. This might be like for evaluating in Python. Is that what it means? Then we have motion types. We can have character-wise, line-wise, block-wise, or unknown. That's ways of moving around the file. Arguments for operators. I don't know what an operator is in this context, but we have current or pending operators. Some register to use for the operator. Type of current cursor position. We can force the motion type. Something about deleting users. We have start and end of operators, which are at position. So maybe a position is the thing that has a start and end. So I guess you like have highlighted an area and you can operate on it. And are these the op types here? I don't think we've seen the op types yet. Whether we're in the visual area when we're operating. And if we're in, if it's a block mode operator, like I said, operates on a block at a time, then we record the start and end of the block. And some stuff about trailing white space for yanking. Okay, and then we have command arg, arguments for normal mode commands. Hey, Elsie. Yeah, you're right. I actually have no idea whether I can. I probably can. Let me try it now. I will do it once it's recorded for sure. It didn't occur to me that I could change the description or title as I'm streaming. So let's actually try it. Um, let's see if this works. Seems to be okay. Hmm. Um, being this distant second best editor and all that. That's right. Yeah. So with respect to reposting, just another FYI, I mentioned it yesterday, and I've gone back and forth on this, but I'm not gonna. I'm gonna try going forward to leave the live streams up as VODs rather than repost, and hopefully it'll work better this time. Now that I know kind of more of what I'm doing, so I'm gonna leave this up, and when I leave it up, I'll rename it and make sure to put like the show notes there and all that stuff. Yeah, sorry that that's a really good idea. Changing the whatever it's called, the title. I mentioned earlier. I mentioned when I started that I've been up since 3 a.m. Because of the baby. So I've been a little bit loopy here and there. All right. Okay, so we've got arguments for normal mode commands. Command character, first composing character, second composing character, yet another character. These are charactery things. Op count, count before an operator, count before a command. I'm not quite really sure what's going on, but this is all stuff about strings and characters. And maybe the command is changing text or something. And or I don't know. So whatever normal commands are doing, I'm sure if you use Vim, that you have a sense of what sorts of things people are normally doing. Thank you, Samir. She's about a month old, so still very very small, and has much to go on her skills charts. Okay, so move is not. There's not really anything here, and I think we've seen things move around a little bit. So a lot of these I opened at the beginning kind of speculatively because I had no idea where anything interesting was. Now I feel like we've seen a lot of interesting things. I guess now that I'm saying this, let me pause and think to myself, or rather, I guess, think aloud about whether there's anything that I would really want to see in the code that we haven't seen any of yet. There's a built-in LSP implementation. I'm not sure really where that is, but we saw like tags. I don't know if that's considered part of the LSP. I feel like we've seen most of the stuff that that I'm familiar with from Emacs, and I feel like there's nothing obvious that pops into my head, but um, like maybe GUI toolkit stuff, like if there's like GTK support or something, but I don't think that's so essential. I don't think that'll be really specific to Neovim or anything. We haven't looked at the Lua implementation or the Lua bindings, but I'm not sure. There's probably going to be a whole lot of stuff. I think we're just going to black box that now. Okay, so here's message.h. I'm just kind of curious what a message is for. I guess it's for like user UI messages, warn, info, question, yes or no. These are like maybe like modal dialogues, but in text, message history. Yeah, that's what I'm going to assume. Memory. We have allocators and frees. We got some unit testing stuff. That's good that they're testing their allocators. Then we've got arena stuff. And some kvec arenas. And x-free. I think when I looked it up before, x-free was basically like panics if it can't free. Or x, what was it? No, I want x malloc or x malloc. I think the x stuff is like panicky, but this just seems to be a wrapper around whatever x-free is. Samir says, I think they probably were trying to do what Emacs did, C for Lisp interpreting with REST Lisp, but they needed to add it backward compatibility with Vim, so a bunch of other C and Vim. Yeah, I think I think that's right. I think that's right. I hope I hope that if you're a Neovim or a VI user and you feel that's incorrect, feel free to let me know. But that's just a guess. Because I think as I said in the Emacs video, first of all, Emacs predates the like GNU Emacs, and it's the thing that makes it different from a lot of other stuff is it's like a Lisp machine, and so that gives you a lot of extensibility. And it came out in like the 70s, and we were just kind of figuring out the lambda calculus and like what functions were in logic kind of maybe in the 30s. So that's not a big time span. So I think there is a sense in which Emacs is conceptually very, very interesting and different from like a C program. It doesn't make it necessarily a better text editor. It happened to be the one that I learned first, and I've been happy with Emacs. But I do think that it would make sense for something like the Vim world to learn from what Emacs has done well and kind of add more scripting. And so if that's sort of how this sort of thing arose, I think that would make a lot of sense. I'm not just trying to say that they're they're copying Emacs or whatever. Here's more stuff about freeing memory. I guess I don't really care about this. Mark tree. We've got a row and column. Is this a tree of marks or is this marking a tree? We got an empty node, a struct with an empty position and an empty node. M, I'm going to guess is mark, maybe mark type. And I'm guessing this is a tree of marks because we've got an M thing here and an M thing here. So this is a mark tree iter, maybe not. But we do have a node, but it's a node of marks. That means it's a tree of marks, right? And then this is an iterator for it. Internal storage. So this has things like priority, highlight ID, position, NS, and ID. I don't know what NS is. Next something. We can look up key in MT. Yeah, I think MT is mark tree, and I think it's a tree of marks. I'm guessing that mark is kind of like the Emacs mark. Like when a thing where your cursor used to be. Is that how you think of it? I'm not sure, but that's what I'm going to assume. I'm going to plow ahead. Here's a C file. Sometimes there's a comment in the C file. Yeah, okay. So tree data structure for storing marks. Yeah, I was right. Row column positions and updating them to arbitrary text changes. Okay, this is an interesting way to put it. A mark is just a row column position. So it's just a point that you've traced out, essentially. If you think of row and column as XY coordinates in a Cartesian plane, then they're just dots on the plane. But of course, row and column are integers. So you're on some like integer lattice. I've never thought about them spatially, I guess. I've always thought of marks as like I've set a mark and then I'm doing some stuff. So it's always had this time element. But I think that's right. Is that right? There is some ordering, I guess. Also inspired by the design of marker tree data structure of the Atom editor. Atom is like way later than Vim, right? This must be relatively new. 2014. Let's try the blame game. 2019 is when this mark tree is, well, yeah. Okay. There's some tree for marks. Marks are inserted using a mark tree put, blah, blah, blah. Text changes are processed using mark tree splice. All read and delete operations use the iterator, use mark tree iter get to put an iterator at a given position, or mark tree lookup to look up a mark by its ID. Work is ongoing to fully support ranges, which are called mark tree pairs. All right, cool. That's enough for me. Here's a mark. You can set f mark with mark p mark underscore fnum underscore and view underscore. It has a timestamp. And is there anything else interesting? We have a mark global index, convert mark name to the offset. To the offset. We're going to give it a name. We're going to call ASCII is upper on the name. We check if it's a digit. And check some stuff with n marks. I don't know why this is doing this particular thing. We have local index. We turn true if position A is before or less than position B. We're going to have two positions, position types. I'll just do this comparison by cases. Okay. Here's mark.c, which I will ignore. Mark defs. Marks, positions in a file. A normal mark is a line number, column number pair, the same as a file position. And we keep track, so we have an enum for things like whether we've moved successfully, whether we switched buffers. I guess if we switch buffer, we need to, I don't remember if Emacs remembers marks between switches. It must, right? Does it? I'm not sure. Let's like highlight some stuff and then go to another file here. Kill this file. Kill this thing. Yeah, it does remember. It does remember like marks and highlights. So I guess when you change buffer, you might need to like pull out whatever the previous mark was. Changed cursor line and some other stuff. You can configure the movement of a mark. And there can be some global marks and some local marks. I don't know what the difference is between global and local marks. And to define a single local mark, we have a struct called a file mark, which takes a position t, which we call its mark, because a mark is just an xy pair, just like a position. We have the file number. So I guess this is like we know about all the files, and this is like a index into the known files, known open files. a timestamp when the mark was last set, the view the mark was created on. I'm not entirely sure what a view is yet. We may not figure it out this today. And some additional data from the shada file. I don't know what shada is. Shada has landed. I don't care whether the name feels stupid or genius. This is not really telling me what it is. Is there is this a more general thing? It's a thing from Dr. Who. A Navy patrol vessel. Not sure. Okay, so mapping. All possible map arguments usable in a map command. The map arguments include things like buffer, expression, no remap, no wait, script silence. The left-hand side of the mapping, Vim limits this to max map length characters. What is it doing? I don't know. Some kind of map. I'm not going to dig into it. Here's map.h. Key codes. Key code definitions for special keys. Share data. Thank you, Samir. Share data is shada. All right, so we have key codes. So k null, k special is special, k has 0, mouse. These just seem like standard keys. I thought this might be some of the mode switching. I guess we don't really have a sense of how the modes work yet. Maybe we can find it. Here's executing Lua commands. Description of the values below is contained in the x commands defs file. Need arg whole fold 0 lock OK preview. This is a Lua file, right? .lua. Okay, let's take a command that I believe I will know what it does. So command append has flags bit.bor. I don't know what bor is. BOR, binary or. Yeah, I'm going to guess bit. These are bit flags, and we're going to bitwise OR them. They are bang, range, 0, trail bar, command win. And then the address type is adder lines, and the function is xappend. So I guess this is probably somehow saying xappend is like the corresponding C function, and the Lua function is append. And here's some stuff about the arguments. Just a guess, but that'll have to do for now. Here's xeval, which is not really going to look at. Exception handling stuff. Stuff about aborting. What was it? Xappend? This is for evaluating x try. Let's look at x try. We're getting some sort of stack. We're checking its length and maybe whether we're nesting too deep. If we're not nesting too deep, we're going to increment indexes. We're going to increment the try level. We're going to do some stuff with flags. We're going to decide whether we should skip checks. And if we're not skipping checks, then we'll do checks, I guess. But where did we execute anything? I don't know. X catch. Here's finally. We've got some sort of try catch finally support. We got some cleanup stuff. We can enter cleanup, leave cleanup, cleanup conditionals. I think this is, so at some point we should probably take a look at some Lua implementation. I don't know if Vims is the place to do it, but this pattern of extending like a C or C++ code with Lua scripting appears all over the place. We've run into it a few times with game engines. I don't think we've ever dug into what one really looks like. So at some point, I think we should do that. There's also other scripting languages, like sometimes people support Python scripting. It seems like Lua is simplest. Here's eval.lua, file containing a table with all functions. Here are all the functions. Apps, presumably absolute value, a cosine, maybe absolute cosine. Extend file read table. Yeah, it's a lot of functions. And it tells you the arity, which is args. I don't know what it means to have 2, 4 args. And base is 1. I don't know what base is 1. Fast is true. I guess you keep track of which functions are fast and allow them. At times you don't allow slow functions. Here's draw a line. It's got some struct with rows and columns. Why would you want to draw a line? I guess let's just figure out what sorts of lines it's drawing. This okay. Functions for drawing window lines on the screen. This is the middle level. Draw screen is the top, and grid.c / screen.c is the lower level. I guess this is a grid line. In fact, I'm confident enough to close the file. Digraph. This should be directed graph, right? I guess the header is not so interesting. Code for digraphs. Oh, no, digraph as in a combination of 2 characters. Orthography. This is for support for like, SH is a single sound, but it's 2 characters. So I guess as a text editor, Neovim might need to know about those sorts of things. I assume is what's going on. I'm not sure. So decoration provider, I guess for Lua decorations, we see Lua stuff. Here's decoration.h. Actual decoration data is in xmark.def_defs. What does decoration do? Decoration struct has some vert text and a vert line. I guess virtual text and virtual lines, a highlight group, virtual text position, a highlight mode. Some stuff about whether we're end of line, whether stuff is hidden, conceal, tri-state spell. Maybe tri-state is like true, false, and some other truthy value. Decorator priority, column, and some other stuff. I don't know what we're decorating. Yeah, I definitely would have assumed. Well, yeah, I think that's a natural assumption. Since we've seen so many, seems like everything is a directed graph. At least for a while, we were doing a bunch in a row that everything just boiled down to directed graphs. So decoration, I guess it says add highlighting to a buffer bounded by 2 cursor positions with an offset. Okay, so decoration is basically highlighting, which we're going to ignore. Debugger. All of these headers I opened, but none of them really have any data. Here's debugger.c. List of breakpoints. We're going to keep a list of breakpoints. Debuggy. Breakpoint number, type, name, etc. What else are we going to do? We have do debug. Debug mode. Repeatedly get X commands until told to continue normal execution. EX. Is EX a debugger? Okay, so it's a text editor. And so do debug is going to do some message scrolling, save state, maybe did error message, command silent, message silent, whether stuff is silent, reader off, redirect off, type ahead buffer, whether type ahead is saved, a pointer to command line, pointer to whatever P is. These are all strings, I guess, and a tail. We're going to define a bunch of stuff. Oh, this is a huge thing. I thought we were going to end at define, but repeat getting command and executing it. So we're going to have this infinite for loop. And we're going to use X, I guess, as a line, probably a line-based text editor, it seems like. Get command line prompt, debug break level. What I don't know is like, how are we, this is an interface to some debugger. But is it an interface to any debugger? I'm not sure. What are some debuggers like GDB? I'm not sure. I guess it's your job if you're a debugger to support Vim debug mode, perhaps. I'm not sure, but I'm not going to dig too much into it. Cursor, I think we've seen some cursor stuff. Context, I was just curious whether this is an important fundamental type. And we've got some stuff for registers, jumps, buffs, and global variable. Okay, yeah. So basically global stuff. Like buffers are essentially global because you should be able to access them from no matter what buffer you have open. You should be able to open another buffer. Jumps, I guess jump list is global because it's going to span across buffers. Like if I'm going to jump from a symbol perhaps in the C file, I might end up going to the header file, which would be a different buffer, presumably. Registers, I'm not sure really what it's doing with registers. Maybe because it doesn't, in the same way that Emacs is a Lisp machine, maybe VI is a register machine. Let's see if you can find anything about registers. Is Vi a register machine? What's that Bard? Oh. Text editor. Use registers. And since Bard knows less about, so Bard is not trained on coding the same way that ChatGPT is. So I'll ask both of them. And then ChatGPT gets angry if you leave it too long without asking it a question. All right, ChatGPT, what say you? They're used to store and manipulate text data. Okay, registers can be thought of as a set of named containers where you can store text snippets and later paste them in your document. So kind of like a kill ring. Registers are a way to store text in Vim. I think Emacs has registers too, right? They can be used to store text that has been copied, cut, or deleted, and store text that is about to be pasted. Okay. Emacs has register-like things. I think that they are called registers, though. Okay, yeah. Emacs registers are compartments where you can save text, rectangles, positions, and many other things. This is blindingly white. Each register, yeah. Okay, very cool. So you can store storing the registers, and they go in the context, and that's really all that's there, and presumably some functions for manipulating them. Context is C, I'm going to ignore. Channel, I think we were curious about before, and we decided it could be a bunch of different things like a proc. Not really sure what proc is, but socket, standard IO, standard error, internal. Something about pipes was down here, and then we had RPC here. We've got some callback stuff. A channel has an ID, a reference count, a multi-queue of events, a channel stream type, which is a union of all this stuff. Whether it's RPC in RPC state, what kind of RPC system are they using? And more importantly, is there a gRPC based Vim implementation? Here's channel devs. There's some stuff about RPCs in here. Message pack. Is message pack a RPC thing? Is it like a message pack? It's like JSON, but something that I didn't see the end of. But fast and small. So they want to be like Protobufs. Maybe they want to be split the difference between JSON and Protobufs. An efficient binary serialization format. But it's faster and smaller. I feel like we have to now ask Bard to compare message pack and Protobufs. What did they call it? The binary serialization format. So Samir is saying with Vim, registers are similar to kill rings. For example, you could do +y to copy text from a Vim buffer. Yeah, to a system clipboard and P to paste. And channel seems to be similar to Golang channels. Yeah. And communicating yeah, okay, communicating sequential processes. But they use Unix files and pipes as the underlying thing. Okay. Cool. So Bard is familiar with message pack. And we also get this kind of this overall kind of message at the end. So compare and contrast message pack and protocol buffers. So message pack is small and efficient and easy to use. Con, not as human readable as some other formats. Protocol buffers are human readable, widely supported, and efficient. More complex to use and not as small. Which to use? If you get some sort of table. Protocol buffers are larger? Is that right? Message pack returns only dynamically typed data structure and provides no automatic structure checks. I don't know which one's smaller. Message size. Message pack 2.1.c payload size is not as small as Protobufs. It still got better result on the other metrics. So this Medium article is claiming that message pack is better in their benchmarks. Serialization time. Message pack is I think JSON is faster to serialize than the message pack. I'm not sure if I believe that. Is that true? I mean, than Protobufs. I have no intuitions about message pack performance because I just heard about it. But here's channel.c. I guess I'm not really going to look into the implementation. Buff right, I guess we'll ignore. Buffer.h. The buffer should basically be the like a visible file. When you've opened a file in the Neovim text editor, that associates a buffer with the file, and the buffer should have all the text of the file in it. But it's like the software representation, so you can do other things with that text, like highlight it and whatnot. And with that in mind, I'm not really going to look at buffer because we at least know what it does. We don't know everything about its implementation. I feel like Proto, so Samir says, I feel like Proto has to be smaller. The whole Proto format means you can easily determine the size of a message. But because you can't with JSON, each field will likely need to encode size per field. Yeah. Also, JSON doesn't, with JSON, you, Protobufs, you're not sending the field names, right? So JSON has to send all the field names. I don't know if that means it's faster to encode. Maybe by encode, they mean once you've typed it up, you don't have to do any processing. But with Protobuf, you have to like take the name of the field and replace it with like, it would depend on the language, right? So I don't know what happens in C++. Maybe in C++, like internally, it's never represented as a field name. It's just represented essentially as some enum that has an integer value. But at any rate, it seems like JSON has to be larger. I don't know what message pack is doing. If they're sending like field names along with things, or if they do like variable length encoding like Protobuf does. I know there are things that are trying to be faster than Protobufs, like something proto, Cap'n Proto, which I would reasonably believe are faster than Protobufs. But I'm not sure I'm convinced that JSON serializes faster or deserializes faster. But perhaps. Here's term info. Term info is term family. Term info is BSD console. So I guess term info, your terminal has some info associated with it. And it might tell us that we're on BSD. And then we might have to do some like special casing for free BSD stuff. There's a built-in term info DB, Unibilium, and it might fail to load something, in which case we do some other stuff here. We do not attempt to detect X-term pretenders here. I guess, I don't know what a pretender is. Maybe it means that terminals say that they're X-term when they're not, just to get programs to support them. All right, so this is like looking up stuff in a terminal DB, I guess. That's maybe not so interesting. Here's some sort of tree sitter support. I suspect at some point somebody will request tree sitter, so I'm not going to look into this here. There's probably better ways to learn about tree sitter. Here's some sort of Lua executor or executor, which I'm not going to look at. Here's more executor stuff. Actually, maybe let's look at the C file, just to see if there's anything fascinating. Errors, CFP call. I was thinking initially callback, but I don't know what CFP. There's no B's. But yeah, LEV callbacks. I don't know. Here's a CB. Here's callback stuff. Okay, so some sort of Lua support. Here's a converter. I guess a Lua converter, which I'm going to ignore as well. And here's the source directory that I opened by accident not too long ago. How many more Firefox windows do we have of tabs of did we look at main? We have stuff like missing, garbage. We have loop init, event init. So I guess this is the event loop. We're initializing the event loop. I suppose I'm going to call loop init on the main loop. And I don't know if the main loop has the same loop struct as the other struct. It might have a similar struct. And I guess we're going to have some resize events, which we're going to call multiqueue new child of the main loop events. And that's going to be like, I guess, a resize event queue. And there's an early message pack RPC initialization. So I guess if we had read this file first, we would have known what the RPC mechanism was. And so they're going to init some handlers and some input init and signal init, I guess, for listening for input and listening to signals like control C or whatever. And oh, no, I guess this is all supposed to be message pack stuff between these two things. And then we're going to init channels and init terminal support, I guess, and then init the UI. Then we're going to time message event init, I guess, to know how long initiation took. Then we can do teardown. And I guess teardown's not so interesting. Early init, perform early initialization. Whatever eStack is, command line init, eval init, runtime init, highlight init. What is this called? I don't think we called it an event init. Does early init call event init? I'm not sure. Runtime init. Maybe runtime calls events. And I think this is more init stuff. We're doing some asserting. Stuff about allocating grids, debug levels, clearing, prepare a screen now. Starting equals no buffers, screen clear, win new screen size, time message clear screen. Something about standard ins and I guess pipes. Foo, pipe, and Vim. And here's some default mappings, like some Lua stuff, some API, whatever API clear is. Execute dash command arguments. So I guess if we can start Vim and pass it some commands on the command lines, and I guess those are called pre-commands, and it will execute them here. We might do some file type plugin enabling and then source the startup scripts after we've executed the commands. So maybe your commands can't affect the startup scripts or something. I mean, it's not obvious which one should happen first, but it seems like commands, pre-commands happen before your startup scripts. So we can source the syntax/syntax.vim scripts, I guess, for syntax highlighting. We do this after the user startup script so that users can disable syntax highlighting with syntax off if they wish. Okay. Then we can read all the plugin files. We'll set the window layout. And some recovery stuff. Set init3, some option defaults after reading. Set option defaults after reading vimrc files. Shada read everything. Read in registers history etc. from the Shada file. So I guess this is, I see. So maybe Shada is about storing like internal state between runs of Vim so that it will record things like your registers. Handle a quick fix. So I guess if there's fixes like patches before the next release, you can handle them there perhaps. Start putting things on the screen. Scroll down before drawing over it. Scroll screen down before drawing over it. Clear screen now so file message will not be cleared. Okay, so starting equals no buffers. No wait return is false. If we're not in X mode active, the message scroll is false. Read a file from standard in if some stuff happens. Set mouse. May start using the mouse when we get to line 525. Then we're going to, I guess, request that the current window is redrawn later with whatever UPD valid is. And I guess set no wait return to true. Is this like a poor man's future? Like async? I don't know. Then we'll create some windows. Create the requested number of windows and edit buffers in them. Also does recovery if recovery mode is set. So we'll call create windows. some trim stuff. We'll apply auto commands. We might have to start with an error file, in which case we jump to the first error. And if we've opened more than one window, you can start editing files in other windows. And then, is there anything else interesting? So starting is equal to 0. And then we're going to do whatever auto change dir, I guess. And adjust default register names. That's maybe not so exciting. I feel like we're almost ready to edit. I guess this is the end here. And then we're going to end. Okay, here we go. The main loop never returns. So we're going to call normal enter with whatever false is. So normal enter is going to enter normal mode. And so whatever hope I had of ending this live stream right now, I feel like I now have to look at normal enter, because that's going to be the loop, I think, that switches between the modes. So now that we've seen this, let's see if we can find it. Will cscope help us? Was it just called normal mode? Normal enter. I bet it's in normal.h. Normal enter. I don't know. But let's go to normal.h. Okay, so here's normal.h. Let's look at normal enter. Normal enter, we're going to create the normal state. We're going to call normal state init. Set whatever no exit mode, which is passed in when we called normal enter. We'll set the state top level to something depending on whatever the first argument of this function is. And also depending on whatever no X mode is, the second argument. Then we're going to call state enter on the state we just created. Where's state enter? It's in nvim state. The state enter, we're going to have an infinite loop and check some stuff. Wait a minute. I don't want to be setting a mark here. And then we're going to execute this state. We were passed in Vim state as S. And we've got some goto, it looks like. Get key. Apply mappings first by calling vpeakc directly. If vpeakc returns non-null, there's a character already available for processing, so don't block for events. vgetc may still block. If I run cscope d ittl. Oh no, that's just saying it'll open up. Okay, I'll try that. Do we need to pass it the cscope file? Well, we can't find the do I need like C++ scope? I don't know why I can't find normal enter. I was in Emacs, right? Okay, so this is whatever, some key lookup it looks like. Let me process events on the main loop. What is this doing? If vpeakc returns null, vgetc will block. A blocking wait for a character should only be done in the third case. It's doing some event loop stuff. We got some if defs. It seems like we end here. So we're going to get execute result is going to be called, we're going to s execute on s and whatever the key is. So key, I'm going to guess, is some sort of context stuff. And s.execute, we're going to execute on the state. If we don't have an execute result, we're going to break. Else if execute result is -1, we're going to call get key. Now we need to know what Vim state is. If state is in the header. We're going to type def Vim state is a struct. Which has a check and an execute, a state execute callback. And then here's normal state. So normal state has a Vim state in it, and some stuff about whether the command finished, Control W, need flush buff, whether the buffer needs flushing. You can set previous count, previous got int. I don't know, I guess whether got int was true. Command window, no X mode. Top level normal mode, operator arguments, command arguments, mapped length, index, old position. But there should be some implementation. So the execute is going to be set to normal execute. All right, we're getting somewhere. The normal execute is going to do what? It's going to set the key S arrow C to the key, set some other stuff. If a mapping was started in visual or select mode, remember the length of the mapping. If restart edit is 0, we'll do some stuff. Checking if visual active and visual select. In select mode, typed text replaces the selection. Okay. Some stuff about flushing. Normal get command count s. We have some while loop. And I guess what is wet s? S is basically the same as the thing that we passed in. We're trying to get commands from there. It's a while loop, so maybe we can keep putting commands there. And we'll check it against, I guess, a keyboard event. In which case we'll save the count value so that op count and count 0 are exactly the same when coming back after handling the k event. So we'll save some stuff and handle the keyboard event, or k event, presumably keyboard. Whatever this is, if we're in the middle of an operator, including after entering a yank buffer with quotation mark, and we had a count before the operator, then that count overrides the current value. This means it's effectively is that commands like 3dw get turned into d3w, which make things fall into place pretty neatly. If you give a count before and after the operator, they are multiplied. And why are there so many 9s? If op count is bigger than or equal to whatever this long thing is, divided by ca count, then we'll, I guess this is like the max operator count. More juggling of count and remembering stuff. Yeah, this is all kind of wild. I am not going to really go through and read this implementation, but normal.c is a place to hang out if you're a Vim user. What's another Vim mode? Insert.c. Let's fall back on grep. Was it Vim state? How do I quit? How do I quit cscope? Okay, I'm going to give up quitting cscope. But I will look for, I think Vim state was the thing. Let's see. Edit. Is it called edit? Maybe we can see we've crept into the tags file. So it says vim state, 92, 3198. Is the state the file name? At any rate, I'm guessing it might be edit.c. Okay, insert state. It's not called insert.c, it's called edit.c. And then I'm going to guess insert execute is going to be the name of the execute function. If stop insert mode, then do some stuff. Insert mode ended. Okay, so we might yeah. And we have some special handling of keys while the pop-up menu is visible. Pair, for, or stop Control X mode. This doesn't do completion, but it does fix up text when finishing completion. Okay. This might be the main loop here. Control / Control N goes to normal mode. Okay, maybe this is looking for a command sequence to go to normal mode. And then setting SC to do digraph. We're looking for digraphs. And okay, digraphs because it's okay. Digraphs because Vim has an impoverished notion of key chords compared to Emacs. So maybe a digraph is looking for things like Control V, Control Q, and so that would make sense for why you would need to look for digraphs. So if you use Control V or Control Q, and we're in X mode command line, then we're going to call insert do completes. This seems to be handling cursor movement. If it's keyboard left, whoa, what? Case key left, we're going to set SC to K right. And if K maybe super left, we'll set SC to K super right. Is C supposed to be the opposite? Like, is that for the undo information? I don't know, but this seems to be keyboard movements. So Samir is laughing at my my representation of Vim notions of key bindings. If key model contains start cell, okay. So yeah, so this is where the states are. So I'm glad we saw this stuff. I'm not going to look too deeply at it. They are kind of one giant ball of implementation when you finally get down to this level, and I think that they are. This looks pretty understandable if you are motivated to understand kind of like what the modes are all doing. But since we've been here for nearly 4 hours now, and I'm sleepy, I'm not gonna really dig into them. And I think that's really the last thing that I wanted to see. But since this is since this is a Vim related video, and we've already done an Emacs video, I feel like we should ask ChatGPT to weigh in on Vim versus Emacs. I'm going to ask it. I have to think about how to ask it this question, because ChatGPT will just tell me it doesn't have an opinion on anything. So I'll say compare and contrast the best and worst points of Emacs versus Vim VI. And I'll ask it to use as many words from the jargon file as you can. The Emacs and Vi are two of the most popular text editors among programmers and system administrators. While both have their strengths and weaknesses, they also have a cult-like following and a rich history within the hacker community. The best of Emacs is its unparalleled extensibility, with its list-backed extension language, allowing users to tailor the editor to their specific needs. Emacs is capable of almost anything from acting as a web browser or email client to playing games or displaying images. The editor is also highly customizable, with its own elaborate system of modes, hooks, and key bindings. On the other hand, the worst of Emacs is its notorious Emacs pinky, which refers to the pain and strain that can develop in the fingers from Emacs's reliance on awkward key sequences. The editor is also known for its initial steep learning curve and for being relatively slow and resource intensive compared to other editors. That's true in like the 1980s. Is that still true? In contrast, the best of VI is its efficiency and simplicity, with its modal interface allowing for rapid text manipulation and minimal keystrokes. Vi's powerful command language and ubiquitous availability on Unix systems have made it a favorite among sysadmins and power users. Vi's keyboard shortcuts have even been compared to the command line kung fu and the jargon file. That's the best you can do, ChatGPT. However, the worst of Vi is its lack of extensibility compared to Emacs, which it seems like Neovim has solved, right? So Lua and Vim Script, I think if your concern is that you want a more extensible Vi, it does seem like Neovim has solved that, which can make it more difficult to customize or automate certain tasks. The editor's modal interface can also be confusing for beginners, and some users may find its minimalistic interface to be lacking in features. In summary, Emacs excels. I'm not going to read the summary. I'm not in a cult. So Samuel says, I'm not in a cult. I just irrationally believe Emacs is better. All right. So I'm going to tell it, that was pretty good. Thank you, ChatGPT. But I'm going to tell it really needs to use some more 1980s programmer hacker jargon. I'm just going to try again. They're heavyweight contenders in the editors. No. It's using more like, yeah, I don't think it knows what it, I don't know. Yeah, there's nothing, there's no hacker stuff in there. All right, that's okay. Thanks for your attempt, ChatGPT. All right, so that was Neovim. That was actually pretty fascinating. I didn't know anything about the VI or Vim or Neovim codebase. It seems like, as we've said multiple times here, but I'll say it at the end just so that everything's kind of in a recap. It seems like the impetus for adding Lua and maybe better support for Vim Script. I don't know how far back Vim Script goes, but the Neovim people wanted to make something that was more extensible than classical VI, and so compete maybe for some of the programmer mindshare of people who would really rather be using VI but have had switched to Emacs for extensibility or whatever. Or maybe just make a more modern version of a beloved classic, the same way that something like DoomMax or SpaceMax is trying to do for Emacs. So, so that was cool. That was insanely long, but it was a lot of fun. Thanks for all the people who popped in on chat. Thanks to Samir for sticking around for so long and for helping me with a bunch of stuff. And this was fun. So we're going to do another one of these roulettes again soon. I don't think next week. I think maybe the week after. But my schedule is on YouTube, so you can go and check that out. And have a good weekend. I'll see you guys next week. Thanks.